I believe now's the right time to say nyan. That was not the right time to appear though. Hi, welcome. No,
Cheers.
I actually have to move, otherwise they'll bunch up in the same position. Ah! Wait, hang on, I've got the right effect for this. Hi.
Cheers.
Why?
Cheers.
Welcome. I'm stuck in position. Well, I have to say the bottom of the PNG is rather spooky. This one eye in particular is spooky, apparently. Welcome. Thank you for the pats for you. Hi, Pete. I'm again 2D because my camera is going to be used again today.
Hi. Oh my goodness. That's an interesting sound. The camera is currently so close to my face. Okay, they are. You couldn't see the effect. Look at that cheese slice. Look at it wiggle around. Ah. Oh, wait, what? What's happened? Wait, what? Hang on, why is like... Wait. Oh, the camera's stuck to my face. Okay, that was very confusing. So it's just the background. Welcome, Vtuber. Welcome, Sai. Welcome... Hey! James! Hey! Wooly! James again. Hi. James. Hi. I will hydrate. I will check as well. Knees have been saved. Why? Okay, fine, I'll do it now if it's illegal to delay. Jeez. Hold on. Welcome. Hello, everyone. I'm hydrating now.
What the fuck? What the hell? Thank you for the hydration. And now I'm evil, apparently. Even though I'm just a black ominous... Like, yeah, I guess that is kind of evil looking, isn't it? Just a giant shadow. You can't even make out what I am. It's just like a silhouette. That's the word. It's a giant silhouette. What could it be? And before you know it... Oh. I can make the bars... I can make the bars thin. I can see the slice of cheese! Welcome Forwarded, welcome Azrael as well, hi. And Brees, no!
Yeah.
Why? Omni, hi. Okay, that explains some of the cheesing that I got. Welcome Omnum. How are you doing? Hi Chaos. Hi Dockrect. Welcome. Hi.
Pat the imprisoned. Oh, it's one off. I'll talk normally again. Actually, no, I won't.
Pat the imprisoned shadow from...
Yuki's film, just lines and hues, a masterpiece the heart pursues.
Oh,
Her drawn on screens, not flesh and bone, her beauty stands, her charm heroine.
no, shush.
His world, yet depth unfolds, in every glance, a tale is told.
Eastward.
No need for life to understand the timeless grace of Yuki's hand.
What the fuck?
Yuki's lick.
But, wait, why the lick? I can clean myself. Thank you for the kind words. What the fuck? Hi, welcome. That one was really nice. Welcome. Hi. I've done everything right. Did I pause to check? I'm gonna do it again. I think I got made evil right as I was about to do it, or something like that. But hello, welcome. Today's going to be another strange combination of PNG tubing and real life look at the circuit board. I mean, I wish I could get the circuit board to look like it fits in my streaming setup, but that's a little beyond me. It does sound like something that's possible with VR though. I know you can attach, like, you can do a thing where you attach like a tracker to a keyboard or something, and then it just does like the, what do you call it, the almost augmented reality, but reverse. So you're in VR and it shows the pass-through from your cameras just where that tracked object is, so you just see the tracked object in real life, the real life view of it, while you're in VR. Anyway, thanks for coming to my TED Talk. I've never got that to work, by the way, I've just seen people do it. Why am I wide? PNG circuit board? No, it needs to be fully animating as long as, you know, presuming stuff's actually gonna work. Nothing like good as well. Oh my goodness. Indeed. Hi! Welcome, Sheps! Hi! Hi! I'm moving, but the camera's stuck to my head right now, so it looks like the background's moving. Welcome, welcome! Ah!
Käse.
Hi! Hi! I'm normally 3D, but I'm flat right now because my webcam's going to be used for actually looking at not my face for once, much to my webcam's relief. Hi! Welcome, what were you up to, Sheps Almighty? Welcome, Standard as well. And thank you very much for the follow again. Karayon? Hi. Hi, Rhubarbo as well. Why the cheese though? When I'm 3D, I move around and the cheese actually goes in different positions. Let me slide over to one side so that in case anyone wants to slap. There you go. It's a different position. Welcome Tiny as well. I'm gonna shout you out. What are we up to? Let's see. Jeez. Welcome, Sea of Tranquility. Almost shouted out Sea of Tranquility. Sheps. No, I'm trying to press backspace. Ugh, and my keyboard is vertical right now, so it's very hard for me to type. You saw that I typed she by mistake. Okay. I'm actually gonna do the shout out now. But I can't hold up the placard that I usually could. At least I can see what you're doing there. Raid 6 recovery. Oh no. I hope you didn't lose stuff. Hi. Did you receive the help that you needed? Were you able to recover stuff? What is raid 6 anyway? I know raid 5. No raid 0, no raid 1. Ah! No! Please! I'm rotating and I'm walking away with this cheese. I didn't realize that would look so funny when I did that, but I'm off. I am back. Raid 6 is like raid 6. Raid 5? Except 6 times the raid? Oh, raid 1? Oh my goodness. Raid 6 is just raid 5 but twice the parity. Okay, that sounds a little bit... That's not a very inventive name. But nice. That sounds like enough redundancy to get back your shit. I hope you're able to. Hi everybody, hi. Thank you for the pats as well, Alex. Oh, hang on, I never even finished getting through all the redeems that were done at the very beginning of my stream. I've literally only just started. I hope your stream actually went well though. Hi everybody, I should introduce myself before I do things that I already should have done. I'm a strange cat. Normally I'm 3D, but I'm not. And right now, today I'm going to be trying to do some electronics. Which I've sort of done most of the electronics part of. I guess this is more now programming for the electronics. Ah!
Jeez.
Super quick recap. I'm making basically some...
Breads.
Breadsk! Hi Dara! Thank you for the ZK months! Holy crap! The 29 months. Sheesh! How are you doing, Dara? How are you daring, Dua? Super quick rundown. I made a I designed a circuit board. That's basically an LED display. Then I had it made and realized that I didn't read a huge word in the very title of one of the data sheets for one of the components. So TLDR, this board is not going to work properly. But I've very much bodged some stuff together so that it will work to the extent necessary for me to like be able to program some stuff to control the LED display. The LED display is just to show what's happening inside a MIDI file as it plays. You know what? I think I can show you right now, actually. It's like, it's not going to be working, but I can literally go to the camera view and show you. Hold on. Preparing. It's going to be flipping cables everywhere and trying to move them out of the way. Ta-da! It's going to be populated with a lot of stuff, though. Yes, these LEDs are like weirdly sticking up and kind of, you know, weird stuff attached in a weird looking way. This is necessary to bodge it to work because I messed stuff up. There's more bodging on the back. Anyway, there's some stuff. You also see my horizontal keyboard. Oh, not horizontal, vertical. I'm not quite ready for that yet. As you can see, none of those wires are connected to anything yet. I've got to connect them to the Arduino again. Because I flipping put everything away after the last stream because I can't have all this stuff on my desk all the time. I'd rather have a horizontal keyboard half the time. At least half the time. Oh, by the way, hi, Sergeant Pepper as well. I'm not sure I said hi. Welcome. That's an actual board. How the freak do you make a circuit board? Hi, Sheps! Yeah, that's... well, thankfully I didn't do the actual making part. I sort of did all of the design and then sent it off to a company that's actually able to, you know, make physical things, because I can't. The day revision 1 works without any issues has yet to come. True! I mean, the previous board I made on stream works. Although it's... yeah, I guess it is slightly temperamental sometimes, because it does... USB isn't quite enough to power it, and so sometimes only half of it works. If you power cycle it, it usually works. Sometimes one of the controllers doesn't initialize because the voltage is too low. If no bodge wires, clearly a fake. Bodge wires are a sign of authenticity. Oh, thanks! You send a schematic, manufacture a PCB schematic. Yes! I'm using JLC PCB, but I am not sponsored. It's just that I've used them in the past, and so I you know, somewhat knew how it would be, although this is the first ever time I've had one made with the SMD components. If I flip this board over, and I go back to this view that I'm still not ready to show you yet, but I do it anyway. Look, all this SMD stuff, not these little wire connection things, but all of this stuff was thankfully soldered by them, all this really tiny stuff. Here's some more bodge LEDs for testing stuff on the other side. Take a close look at this messy piece of fabric that is trying to protect my desk. Yeah, I know, it's so nice. It's such a shame it doesn't work. It's such a big waste of money. But I'm trying to make the most out of the money that I've already spent by testing as much stuff as I can with it so that I can make as many improvements before revision 2. May I suggest using a bit of tape to make sure the contacts don't disconnect from the Arduino while testing? It's actually not a bad idea, because that did happen last stream a bunch because of how I was twisting the wires. That's actually a pretty good idea. I do have, yeah, I can do that, yes. Thank you for the suggestion. Mark 2 gonna be pork? It's gonna look hopefully the same, but like actually fucking work. Because I like the layout of stuff. Thank you for the pads, Yama. Not sponsored yet? Oh man, that'd be so cool if they sponsored me. I would take that. I've had nothing but good experiences with them so far, so yeah. But it's not sponsored, so they can pay if they want to hear any more nice words from me. Hi Yama, it's not too bad. Thank you very much. Hope you're doing alright as well. No blinking lights? There will be some blinking lights, Jockebro, there will be. You're daring your best. Thank you, Dara. Oh, daring your best, yeah. Daring your best. Wait, hang on a second. Have I missed any of the, failing at RAID 6 recovery? Wait, hang on. Wait, is there a recovery? Oh, it's a recovery challenge. Oh, thank God,
I have
chefs.
2 number 9s, a number 9 large, a number 6 with extra dip, a number 7, 2 number 45s, 1 with cheese, and a large
Oh my
soda.
God! The timing! That was excellent, Spitfire. What the hell? That was so good. That was great. That was impressive. And it was Cat saying cheese as well in English, so it works, you know, with the English TTS. Hi, welcome. I'm glad it was just a challenge, Sheps. For a moment I was worried, or for a hot minute I could say, I was worried that you know, it might have been like out of necessity rather than as a challenge. Can't we see Mark II electric feature creeperloo? Oh no. I'm really trying not to do that. Not just because like I don't want to spend more time. Like it's not that I don't want to spend time making sure that it'll work and like making it better. It's more like the more stuff I add, like I have a version.
PTABLE messages.
It's because I'm wanting to imagine actually storing the history of your chat. Couldn't be me. I wish I did though, because then I could see how many pieces of cheese have been thrown at me historically. That ship is long sailed, something, I don't know. Oh yeah, right! Hold on. There's another big announcement I have to make. It's not really an announcement, it's a thing I should have said before. Hi. Hello. I'm moving close to the camera for this one because it's important. And because I've got nothing.
Cheese.
So, during the last stream...
Puree.
I should have expected this. Sailed since long has, yes, exactly. The boat left the station a long space ago.
Cheese.
Whoa, that's a pretty interesting switcheroo from the camera. Okay, so on the last stream, I didn't realize somebody mentioned at one point, would it be possible for you to desolder some of the stuff that the people have assembled for you? Not that I could like do this to fix stuff. This wouldn't be enough to let me fix things. The problem is in the inner layers of the board, so yeah, good luck fixing that. But I said, no, I don't have the ability to desolder it. Basically, I've had like a little sort of hot air SMD soldering stuff on my throne for a little while, but yeah, blah blah blah. And the conversation just trailed off quickly. Anyway, I didn't realize until after the stream that somebody who chose to remain anonymous bought the goddamn SMD hot air soldering station on my flipping throne, which is fucking amazing. I didn't realize at the time because I didn't have any working notification for it. So anyway, I have that now. That arrived the very next day, and I have used it, and I've been practicing desoldering some SMD stuff. So thank you, whoever the hell you are, if you're here. Thank you very, very much. Anyway, I believe the same person also bought the little flush cutter snips things that were on there as well, which were like 10% of the price if I remember rightly. Thank God. Or maybe a little bit, I can't remember, much cheaper anyway. But that's very much appreciated as well. I have been using those a little bit as well. And actually that is the reason why, if you take a close look at this, actually no, fuck it, let me actually connect stuff up first. Keep on going to the webcam view before I'm ready. Anyway, basically I'm not used to using cutters that cut properly flashed, and so when I was cutting some of the like legs that were coming through the board on the other side, I kind of cut them a bit too short, like really excessively short. It looks like the board has been sanded down. Okay, let me connect the wires now. Nova! Hi! What do you build your vtuber setup? I used Unity. I used Unity. Thronifications. By the way, the most ridiculous thing is that I have a system set up to monitor Throne for notifications, and like I get the notifications in like at the code level. I just don't have that triggering an on-screen notification. I'm so stupid. It's like the minimum amount of work left. All I need to do is like record another little kind of sound, and like me playing that. With all of the little notification sounds of me just playing little thing like live on a keyboard. And what the fuck? Why is there so much phlegm in my throat today? Anyway, things nobody wanted to hear. So I just need to record 2 more of those. Like one for like throw notifications and one for what's the other thing that I've been meaning to have sound alerts, right? I don't need a sound for that because the sound alert itself is the sound. But that's meant to trigger an on-screen notification and as well. But I modeled a goddamn speaker, like a hi-fi speaker as well for that. But I just don't know how to do some of the visual effects stuff. That I wanted to do with it. Anyway, yeah. One day I'll fucking add that. That's the second time this has happened. Like, someone ordered something and there was no notification, which is, anyway, shaders? Very, very likely. Almost certainly, actually. My M1 MacBook has been getting desoldered for the past 3 weeks. What the hell? By you? Or, like, at a repair shop? Or? Okay, I actually need to switch to this view. I'm not going to be seeing anything interesting on the webcam right now, except for the USB cable that will be connecting to the Arduino. Look, it's the USB cable. There it is. I just need to look at this. So X0 should have go to pin 10. Yeah, these are all going to be twisted around. Because wait. I'm being silly. They don't need to be twisted around. Because the wires here, those wires were sort of assigned in like the order so that they would go like to these pins on the Arduino Mega when the board was the other way around. But I can just type different numbers in, like I can assign different pin numbers. These are not the final pin numbers. I don't need to be beholden to this. Past Uke has no control over me right now. Screw that. I'm changing the numbers. I'm also turning this off because it's pointless. I'm also going to turn off... where's the entire thing? Where's the whole goddamn thing? Where is it? There it is. Get out of here. I'll turn it back on soon. Once I have anything to show. Rossman's repair. Oh, Louis Rossman. Okay. I had to get a new board, desolder what they could off the old one, hopefully glue them all back to the new one, on the new one. Interesting. God damn, interesting. Good luck. I was trying some compute shaders this week to try out the new Godot compositor effect stuff. That also sounds interesting. What is that? Is that like a way... Is that sort of similar to the post-processing in Unity? Well, no, it's not, is it? Because they're compute shaders. So when you said compositing, I was imagining like some way of changing on-screen effects from a shader, but then I realized that's not a compute shader, is it? On Unity. Okay, I'm just connecting up some wires. So ground is still gonna be ground. I don't feel like redefining what ground what ground is. Everything else though, let's change this. Right, we're going left to, or right to left now? Yeah, right to left. So this is gonna be pin 2, 3, 4, 5, 6. I don't know if it's doing right, by the way. 7, 8, 9. I don't know if I ever said that. I said hi to Nova. Okay, we've changed those numbers around. Now I just plug them in, and then hopefully it's all magically gonna work, and I'll switch to the view, and life will be perfect, and other fairy tales. Have a lovely stream. Thank you very much, Yama! Thank you, and good luck with the work. It's probably too late, but thank you very much. Hope you see this in the VOD. It's a bit of an assumption. Pin numbers are absolute and immutable. Do not change that which is carved in stone. Look! You're the boss of me. Pin numbers aren't the boss of me. Now the thing is, I'm not gonna be using... Even if I change them, even if I didn't want to change them now, I would be changing them later. Because, I want to use more efficient things rather than having to use digital write and stuff to set every flipping thingy. I want to be able to write to ports to address X and Y. So just like one port write operation to set up all the X and Y pins rather than 5 individual digital writes. Even a single digital write being slower than the port write, so well over 5 times slower. I'm using UE5 for my major engine explorations. Oh, okay. Are you thinking about like for a streaming setup as well? So Slick for 3D going back to Godot, that would be interesting if there's new compute features. Does sound interesting, doesn't it? Invoke compute shaders to modify them, so you can do stuff with them. Wait, hang on. I've been missing Stu messages. Basically, at some point during the rendering process, it lets you hook up a callback and gives you access to rendering resources like color, texture, depth, texture. That sounds pretty cool. What the hell? That sounds really cool, actually. Unrelated in no way based on what is about to happen. Do you have a fire extinguisher handy? I have Nyan juice. Okay, let's move these off to one side. Put the USB cable underneath. Power's still all off at the moment, so we're safe at this exact moment in time. The worst that could happen is, I guess, is that I could kill all USB ports on my computer. And not like kill permanently, but make power to them get cut. Which would end this stream as well, effectively. Because sound would immediately break, and yeah. I was going to say webcam as well, but that doesn't really matter because I'm being a PNG tuber right now. But hi Lonk! Hi Meat! Welcome! Oh man, the wires are still going to have to be twisted actually, because I need them to be not in the same position where the webcam is going to be. Maybe taping the wires will be a good idea. I shouldn't be moving things around that much this stream though. I mean, I'll be moving the webcam a whole bunch, but I shouldn't be moving the board. I don't think I'm going to do any soldering. Wait, I didn't do soldering last time though, did I? Now think about it. Now that I use my brain for a moment. It's rare that I do that. Positioning. Ah, I'm pressing arrows on the vertical keyboard. Help! Can I move this goddamn keyboard somewhere else? Yes, let's do it. Oh, there's such little space here. Oh my god. I'm moving. I'm sorry. I'm trying to move things. I know this isn't thrilling content. Okay, there we are. Can I still reach this button? Just about. Okay, good. I can still reach the pause music button. Alright, that leaves me with a little more space. Not much, but a little bit. Holy crap, my throat. Hi, Finyuki-chan. Welcome. How are you doing? The Arduino is kind of flipping up right now. Alright, let's turn the thing back on, and then, I guess... turn the power on? You know, I'm going to turn the power on without the webcam on because... Actually, no, fuck it. I'll turn the webcam on because if something starts blowing up, then at least I can monetize the loss of my living space. Why am I positioned so high up? Why am I... What is this? There we go. Oh, there we go. Let's turn it on. It's all good. It's all good. It's all good. Some lights came on. I wouldn't do that if there was a short circuit. Okay. Okay. Let's turn the webcam back on then. Nope, that's OBS settings. That's not what I meant. Oh, I forgot to turn the webcam on when I said I was going to turn the webcam on. Right. Oops. Oh my god, it's a UCAN. Hi! So there's kind of two areas that I want to be looking at right now on the stream, I should say. What's the autofocus doing, is it? Is it? I'm not sure it's autofocusing actually. Might need to manually do it. That's not too bad. I mean, you can make out the display. So there's this area here. Oh, right. You know what? I have some show and tell to do actually. Some photos, some nice, really close-up photos that are actually in focus. Unlike this webcam right now. Thank you for the posture check on the hydration. There we are. Still not as cute as Bix's stretching. And the posture check. The hydration. Sorry, I'll do it in a sec. Actually, let me load up this photo and then I'll show you. Which one? Okay, let's do this one. So you might be wondering, how do you have the how do you have the LED displays working if the middle pin is ground and they need to be connected to 5 volts instead? Oh, wait a sec. I just realized this is not going to work. Yeah, never mind. The LED displays are not going to work. I just realized this is not going to work at all, actually. Never mind. I just realized at this exact moment. Well, I'll skip over these photos then because this isn't going to work. But I connected them in a really cursed way that I thought would work. But it's not going to work. Never mind. So, next thing. Let me hydrate, actually. We bodge fire it. Yeah, I can't though because it's common negative. It's not fixable. But I have already, I think I mentioned this in the previous stream. I have at least found the exact equivalent LED display, like 7-segment display, but in common positive form, common anode instead of common cathode. Like exact same size and everything, just the LEDs are flipped. So the way I was thinking of mounting these LEDs is to sort of, we did right because we did try it exactly, is because, it is by using sort of putting all of these displays on, not even necessarily soldering them, just pushing them on. They're quite tight fit because I might have positioned the holes wrongly, but I'm not sure I did. There's just, I think there's a lot of tolerance in the positioning of the holes, of the pins. Anyway, and then dropping these LEDs down so that they just fall down and, you know, touch the floor a little bit away from the board because the display is taller than the LED, you know? And that way everything's going to be like the same height when it gets soldered in position. The top of the LEDs will be the same position as the top of the displays. I thought that looked kind of neat. And the alternative would, like, stop, spoilers. The alternative would be to... Oh, I didn't put the photo on here. What the fuck? Oh, there we are. The alternative would be to have them sit flush like this, which also looks kind of neat. I also might shrink these holes slightly because these pins are quite a bit smaller than these holes are. for the LEDs. And so it's kind of hard to get them to like sit square like this. Like they can rotate quite a bit off. This one's rotated a little bit, but they can rotate even further off square there. So just to get them to sit more square, I might shrink the LED holes a little bit. Let me add that to some notes that I had. Also some slight spoilers. Shrink holes of standalone of square LED sizes. 8-bit? Question mark? I don't know how much by. I don't have a way to measure it. I guess I could take a photo close up and then measure the pixels. Anyway, so in the end I mounted those LEDs, oops, up a bit, like this. I did the same trick as the other things. I just mounted the switched side. Wait, what the hell? Have I cut this leg? Why is it bending like that? And then all of the other legs there, I connected together, and that becomes the common. But instead of going to this square, which is normally the common ground, it goes to this little blob here, which is actually a common positive. Wait, yeah, that's right. And these LEDs would normally be the other way around, right? Yeah. So the LEDs are also in swapped around. So instead of the LED being whatever, it's the same as the flipping LEDs that are already done. These ones, we saw it last stream. We don't need to go over this again. I'm sorry. The last stream I somehow was able to explain this in a much more concise way, rather than waffling on in a way that I can't even make sense. Anyway. And then I also did the same with these LEDs. These are the special ones which are just meant to flash once, depending on the type of message. Do I have a one from above? I don't have a photo from above. Oh well. Well, you're going to get the flipping webcam view from above in a minute, so it'll be fine. And the same again, I joined like all of their legs together, and that goes down to a common positive instead of a common negative. And yeah. Let's like control them or something, I guess. So a couple of things I want to do this stream. I was hoping to be able to test the brightness of the... I was hoping to be able to test... Oh my god. The brightness of the LED displays, the 7-segment ones. I realized I won't be able to do that on the stream with the way I've connected them right now. I can later test the brightness of a single segment. Yeah. And I would like to test display at the same time red, yellow, and green. These are the 3 different LEDs that are colors that are used throughout the display eventually. Hi, the Xerox539. We don't need a space for the logo. There's no logo. PN Duke. Or Duke. Anyway, because the red LED is much brighter than these two. One of these in particular, I don't remember which, is much darker. And the way I was thinking of solving this is by, I can't remember if I said this last stream or not. Ah!
Jeez.
Hi! Or 3 times, possibly, colon. Hopefully it's not going to be that long. Not that many times. Yeah, so what I was thinking of doing is like maybe just turning on all LEDs that should be on. You know, when it's time to update like 30 FPS. I think I did say this on the previous stream. Turn on all LEDs that should be on, and then turn off any LED that is red, like just a fraction of a frame afterwards. It's like say 2 milliseconds. If we're going to update at 30 FPS, that's around 33 milliseconds per frame. Let me just turn off the red like a couple of milliseconds afterwards and keep all the other LEDs on. So effectively, green and yellow will be on constantly, and red will be being pulse width modulated down to a lower brightness. That's basically what we'll be doing there. Yeah, and the only problem with that is that I was hoping to be able to address only the shift register that needed changing, rather than have to be doing this constant scanning through every shift register and turning on and off and on and off and on and off and on and off. But that's effectively what I'm going to have to be doing for not every shift register in total. Like the numeric displays ones we'll be able to get right. Because the numeric display ones only ever control... Well, it's not true actually. There is one shift register that controls these two numeric displays, 7-segment displays. But I think there's also a shift register that controls one numeric display and some standalone LEDs. So if any of those standalone LEDs happen to be red, then that one will need to be passed as well. But some displays, I think, won't need updating, maybe? I hope. Anyway. So I want to test how slow it is to address all 128 plus 8, 136 shift registers. That will be across all 4 of these circuit boards. Obviously I only have one circuit board right now, so I can just address everything on here and see how quickly it does that and then multiply by 4, and then that's how long it would take to update every display on every board, every shift register on every board. That's like the worst case scenario. Data line goes brr, exactly. You know what, I think I'm gonna do that right now. Let's do it right now. We're doing it now. Here's calculator. 891.9. I don't remember what that was. Oh, hold on. There's one more thing I have to change. Hold on. And do this. I've been, in preparation for the stream, that's the thing I forgot to do. Okay, we're done. Did I also post that I was going live on Twitter and Discord? I think I did. What a good streamer I am. What a very professional, completely keeping up with everything that I should be doing streamer I am. Anyway, right, this should all work. Debug pin A7. I did use that for something at one point. Okay, so on the one hand, this is going to be not doing any processing of like messages that will eventually be received over MIDI. Hi Willy, welcome. Hi cheese. I'm flattened though right now. On the one hand, this is gonna be like over optimistic about how fast I can do it because I'm not processing any MIDI messages and like reading from memory to see which LEDs should be on. But on the other hand, I'm using digital write, like in a very hot loop, and digital write is slow as hell. So this is probably actually a worst case scenario because I reckon it's going to be slower to do these. But all these digital writes will be replaced with one write to a port, these 3 specifically. And a couple of bit shifts and masking. And I reckon that'll be faster. I mean, I know it'll be faster because I've done a similar thing with a huge LED message display in the past. Which I did not make. But I did write software for. I just realized at this point, talking about probing things, I don't have my probes scope out. Hold on. Like I said, highly professional streamer. Okay, I got them. How's the wall doing? Alright. What do I want to be measuring? I guess all I want to be measuring is the, like a reference pin, this little debug pin that I pulse. So essentially I want to, yeah, you know what? I think I just need to run the existing code that's on here. I don't even care that the pins are like going to the wrong things right now. I'll just turn off power to the board, which I already have, and run it and see what the Arduino does. Like I don't need this to actually be connected to the circuit board at the moment. So this is turning off the, oh no, I do need to change this slightly. This is turning off the MISG thing. For all of the Ys and all of the X's, we're doing this. And then let's do the message pins afterwards. Okay, so that's not message ones. And the message ones are going to be identical? Well, not identical, actually, just the X. It's just the X, right? So the message pins range from 0 to 1. The message shift registers, there are only 2 of them, so it's 0 and 1. So I only need to do this. and then transfer, and then transfer. Also, this is kind of worst case because we're doing 2 of these updates, although this is just SPI, so it's super fast, whatever. This is erring on the side of, I think, worst case. So if this is fast enough, then, you know, it's, that's good. Would you mind zooming in a little bit? Oh, sorry, yeah. There you go. Sorry. Is there a way of doing this as well? Oh, there is. Oh, I'm not sure I like the look of that, but it's probably way easier to read. There you go. Hopefully that's better. Sorry. All this, there's no comments or long lines either, so there's no excuse to have the stuff as small as it was. Is this going to increase the size of the text that appears down there? Hope not. Oh, it does. Okay. You know, that's okay. It still fits. Okay. Let's update. This will be just for one board. So I need to like time how long a cycle of 4 of these flashes take. Because this is for all of the channels. The main, like MIDI channels. The 4 MIDI channels on one board. This is for the 4 rows of MIDI messages, which is done by 2 shift registers. Because there are 8 special flashy LEDs per MIDI channel, and 1 shift register controls 16 of those, so there are 2 shift registers. Alright, let's upload. And while it's doing that, which is already done, never mind, I'll prepare this probe. Where's this code for ants? Oh, sorry, what is this comma code for ants? I completely misread that. Not anymore. It's code for beetles. It's slightly bigger. Still kind of smaller. Prepare the probe. Yep. In the words of, who was it? Salvatore Ganacci? Try to relax your anus. How do I connect to... What did I have this connected to before? Oh yeah, that's how I did it. I need another wire for the probe ground. One sec. What? Why?
Kaiser.
Hi, Geets. Welcome. Welcome. Oh, I need a screwdriver as well. Oh my god. Starting to remember why my desk was such a mess last time. And why it took me so goddamn long to actually get to the state where I'm doing anything on the stream. Connecting wires. Away from the mic. One wire goes in. The other wire goes in. And I tighten the screw, and hopefully that holds everything in place and nothing is gonna fall out and go boom. Nothing at all. Absolutely not. No way. My chair is gonna creak though. That's a guaranteed. Okay. Now we're all set up for probing. So we can connect the ground to the thingy. This will be visible shortly. And one of these 2 wires is the data and one of them's clock. Oh wait, I don't care about that. I care. Fuck. Oh my god. Hold on. I have to see everything I just did again. One sec. My god. I have 0 memory. I have 0 goddamn memory. This is literally the last stream I did was this, and I've forgotten already how I had to do things. Things falling out and going boom is good content though. I guess so, but... I guess so. I'd rather things work, but... You know how it is. I guess if people like it, then please. Is my Tsun impression good? Alright, it's far away from mic moment. Alright, screws have been tightened. New, longer cable that can actually reach the goddamn area I'm trying to probe has been attached. And we clip onto it. I move the mic towards me because I just realized I can do that. I remembered. There we go. She says making the thing fall out. What the fuck? This probe is... There's like a little plastic thing that goes over the crocodile clip. Not plastic. Rubber or something. But it's so tall. Like the rubber... The fucking crocodile clip is so tall that it sort of means that it's pushing the thingy open. The unlock, I can't fucking speak. Ignore me, it's not interesting anyway. And I'll just have this elastic band hold this in position. Okay, and this goes down to the pin on the Arduino, which was A7. A7. There it is, the end of that row. Okay. Alright, good to go. Good to go. Now we turn on the Arduino, and now I can show the scope view as well. Not that the scope is showing anything yet, but I'll show you it anyway. Yeah, I don't think we need the camera right now. Not super interesting. I'm not even looking in the right direction either. Is that better? Yeah, perfect. This is the back of the board again, isn't it? Right. Anyway, it's about time we give this a try. After I flip the board back. There we go. Oh my god, I'm just fighting for my life here. Okay, there we are. Have I won the battle for my life? I'm not sure. We'll find out now. Oh my god. Okay, there we are. Now I can show you the oscilloscope view. Oh, I already am. Okay, let's turn it on. Nice. Beautiful. This is the interface for my LED lighting in my room. Watch this. When I turn off my lights. Boop. I recognize that, how that looks anywhere now. Well, just on the scope, really. Well, now I think about it, why are we getting no readings of the... Oh, we are, okay. Never mind, we are. They're just so far apart, okay. Zoom out a bit as well. And upload it. Did I upload it? I think I did already, never mind. Casual wearing of the flash memory due to crap memory. Human memory. The Battle of Uke. I know, it's a hard one. I'm fighting it. Alright, instead of a trigger... On... Which are we using for triggering? Big right channel. Okay, we can zoom in then. Okay, so 4 of these cycles, of these little spikes. That is, that's how long it takes to address every single board with this slow debug write, digital write way as well. So let's measure. Let's take a snapshot. Boop. Let's turn on the cursors. Actually, let's zoom in a bit. We can get more accurate than this. Kind of on the thingy up on the far left. There we are. 1, 2, 3, 4. That's probably close enough, accurate enough. And we'll turn on the cursors. We'll move the first one to there. Wait, where are we? There. And the second one to, so this is 1 cycle, 2 cycles, 3 cycles, and 4 cycle. Wait, 1, 2, 3, 4. I can count to 4. I swear I can count to 4. Alright, it's taking 7.5 milliseconds. Well, if we're updating every single display, it's going to take 7.5 milliseconds. Which is nice, because that's less than the 33 that I wanted. That gives us like 7, 14, 20, and 28. That's, yeah, we have about 3/4 of the time left to do whatever we want. Like process the MIDI messages. The reason I'm not sounding super happy is because, well, we gotta do that. And then we've got to do it again to turn off some of the LEDs. And I was kind of wanting to turn them off, like, you know, really quickly after they've been turned on. And 7.5 milliseconds is not really quickly. That's, like, just running the LEDs at like a 1/4 duty cycle is not actually going to make them that dim. Because do you remember how the big little bunch of 16 LEDs looked on the previous stream? That was with 1/16 or 1/17 duty cycle, which is like way lower, and they were still really visible. So, you know. On the other hand, this is updating every single display. I guess it is often that you'd need to do that though. And it's using digital write, which is the slower way of doing it. You know what? Out of curiosity, let's see how much faster it would be if instead of doing a digital write... Wait. Oh, sorry. That's the old way of doing it. For a second I thought, why is there a delay in here? That's the old way. I'm going to remove this actually. It's worrying me. Loop flash manual, flash SPI. Yeah, let's get rid of this one entirely. Get rid of some of this old testing code. We don't need that anymore. We know it works. I want to kind of see how much slower or faster it would be if just for the pulse, I change it to do 2 port writes instead of 2 digital writes. This will be kind of interesting because this pulse latch is done regularly, you know? It's, I believe, what you'd call a hot code. Hi, Kiswick or Questwick. Welcome, welcome. It's just beginning, really. How's it going? I'm pretty much finally just beginning. Okay, so my latch pin, I hope you're doing alright though. Latch pin is pin 10 now. Alright, where's pin 10? Here it is. So it's controlled by port B, bit 4. So let's write to port B directly. So, port B, bit 4 equals pin 10. You can set the data direction register, I think it's DDR-B, to choose whether each of these bits on the port is set which correspond to pins, usually. Sometimes other internal stuff is not exposed on the Arduino. You can use DDR something to control whether the direction is input or output, but we're already setting up the direction up here. So I don't actually need to do that. We just need to control port B. So I want to toggle this pin. The other things are SPI as well. That's fine. SPI write is not going to be happening mid-latch. I mean, that'd be... What would we be latching if we were doing that? Something not very reliable. Okay, pins 5, 6, and 7 belong to stuff that we're actually using as well, which you certainly don't want to change. So we want to read what port B currently is and force off bit 4. So it's whatever port B currently is. Thank you for the pads. I'm just going to write it like this first and see if I can simplify it afterwards. So it's this, with this bit turned off. So it's this, ANDed with, thank you for the pads. With, oh my god, there's so many pads. Hi, Cabbage, holy crap. Hi. You can't make the ears wiggle. Oh god, I didn't mean to turn that way, sorry. Meow-dee-doo, hi. Or mew-dee-doo, as Reba you could say. Okay, so bit 4, so be 0, 0, 0, 0, 1, 0, 0, 0. Oh, the other way around, sorry. 1, 1, 1, 1, 0, 1, 1, 1. So this one's gonna be forced off. So this can just be simplified to AND equals. So this is turn off bit 4. And to force it on, we just OR equals it with, no, not OR equals, that's not right. Wait, no, that's correct. 1, 0, 0, 0. So if any of the pins were already on, then these ones will remain on. This one will come on even if it was previously off, which it was because we turned it off. Alright, so this should force on bit 4. Ooh, look at that, really nice alignment vertically. Okay, hopefully this will work. Yeah, let's run it. Well, let's upload it first. I'm just gonna turn on the power as well, because I think this should make every LED be coming on in a way that looks dim, because every LED should be turning on and off. So let me see if that works. Let's plug it in. It is not working. It is not working. Isn't a bunch of pads nice for once? It is, rather than the cheese. Yes, it is. Right, this is not working. Let me just put it back to the old way and see if that works, because I didn't actually have the power plugged in when I did that before. Right, that does work. Oh god damn, those LEDs are so bright still. Okay, I can tell you it's a green LED that's super dim on the bunch. You know what? While they're on, let me show you this. This does not look like they're dimmed at all. This looks really fucking bright. This cannot be dimmed. Surely it's cannot be dimmed. What are we doing? Something wrong? Let me show you on the webcam. Boop. Look at this. The green LED on the end there, which is looking blue on the webcam for some reason, is so bright. Like really blindingly bright compared to the others. I mean, you can even see that on the webcam, even with like non-ideal thing. Look at the size of the flare on that one. And over here, the green LED on the end is super dim compared to the red one. Look at the end of this box. I need to adjust the exposure on this camera actually. Hold on. I just want to be able to put the box down to actually keep looking at it. The board is huge. It's pretty big, yeah, it's pretty big. It's funny, I didn't get like a proper perspective on what the size of it was until it arrived. And I'm designing it, and I printed a 2-scale model of it. On paper, if you can call it a model. Okay, let me adjust stuff. I'm going to do this using a program that causes weird things to appear on the screen for a moment, so I'm gonna hide it just in case. Oh, by the way, I finally got to uploading VODs again, which I had to do because they're not live yet, they're just sort of processing by YouTube. I had to do it though because I was very low on disk space again, like getting down to 40 gigs on my biggest drive. So, how do you do this? Capture filter, that's the one. Alright, I should be able to take control of the camera now. Oh, it's already changed stuff actually, I think. Autofocus is off. Okay, now it's on. Gain is there. Let's change that. Turn it down. There you go. Look at that. Look how dark the green is compared to the others. Oh my god.
Never enough disk space.
Abby! Never enough disk space. Thank you very much for the resub. Hi. How are you having? Yods. Yods indeed. Thank you very much. Look at that though. Look how dark that green one on the end is. That's red, yellow, and green. The yellow is darker than the red. I don't think it's like too much darker than the yellow, the red, for me to worry about. The green is. That's crazy. That is actually how it looks though. I know that's how it is according to the datasheet as well. So. And now for the comparison of how bright the green one is compared to the others. Well, it's actually kind of hard to see still. The green being the one on the far left. Ah, you can kind of see. It actually looks green now since I loaded the settings. I fixed the white balance. This is as dark as I can get the exposure on my camera, by the way, I think. Gain is all the way... Oh, wait, it's not. Hang on, exposure is all the way... Is that exposure all the way down? Yeah, it is. Gain... Yeah, you can see once it gets... So for some reason, this camera lets you adjust the gain below 1 times, which all that results in is... Like... You know, the colors scaling down. Color intensity. Okay, there we are. I've cranked the color intensity slider for maximum ridiculous colorfulness. Sunglasses. Exactly, that's what it kind of looks like. Okay, there we are. This is too much saturation though. Holy. Anyway, this green LED on the end is like really, really stupidly bright. Like crazily bright. It's too bright. I need to see if I can find an LED with a green lens still, like these are. And if I just... Okay, you can't even see the LEDs anymore. Wait, why is it not controlling the gain? Hold on. There we are. How do I reset? Hang on. There we are. Is this board color balance alright? Something like that, I guess. Anyway, most of the LEDs there have like the correct color lens, and that's on purpose. I really tried to get LEDs with colored lenses, so you could see what color they would be when they're not actually even doing things. Wait a minute, I need to tweak settings still. I couldn't find colored lens pink LEDs in this size. Or white. Well, where the white is, but it's... Yeah. Okay, it is white. It is colored white, but the pink is also colored white. And then the violet one, which is kind of a little bit UV-ish, which looks quite dim because it's mostly UV. It just looks transparent. Hi, F-Ball. Wait, why did I say hi, F-Ball twice? I think it's because I started reading your message. Expose D's. Reds. That one green at the end... Exactly. For the benefit of the archive. Yes. Exactly. Screaming out light. And the green on the far left is screaming out light, even brighter than the red square ones. Crazily loud. Crazily loud. Also, it seems that they're not actually... Okay, I've plugged power back in. I've plugged power in, but why are they doing nothing? That's concerning. If I reset the Arduino. Now they're doing things. That's... concerning. That's concerning. Have I got the wires connected correctly? This one's off and this one's on. Why? Why am I being sprayed? Hi, Cat! Cat! Look! There's stuff! Some of them are way too bright. Some of them are so dim they look like they're dead. And these numbers will never do anything. Hi! It's colourful, though. The board is... yeah. This is all bodged in weird ways to make it work. And they should be flashing right now. They're not flashing. I'm gonna turn this cam off for a second and move a bunch of things around. Okay. Yeah, they're definitely not flashing though, because these are way too bright. And also, as I turned down the exposure to really, really low levels, you would have seen flickering. Which you saw on the previous stream, and it's not on this one. How's the cat doing there? How beeth the cat? I'm gonna unplug this because this row of LEDs is flipping blinding me. It's so goddamn bright. Every time I unplug this, my monitor turns off and back on.
Cold.
Cold? You're cold? It is cold right now, isn't it? It is actually cold. Look how cold it is. Look. It's barely 22 degrees in my streaming room. That's crazy, actually. It's actually really cold. For my room when I'm streaming. Obviously it's not cold outright. Hi Sleepy, welcome. Sport needs some nuclear energy. Oh my god. I thought it learn for a second. Better today? Oh, nice. Wait, I didn't realize you were that bad. I'm glad you're okay though. Or better. How's Yuke? I'm not too bad. Thank you. I got some sleep. I woke up later than I wanted to, but that was the price for getting some much better sleep than last night, so I'm happy about that as well. 18 in your lounge. That is pretty cool. Previous port B test, did you scope the pin? It should have switched. No, actually. That's a tricky one to probe. Wait, it's actually not tricky when the board's this way up. Actually, it's not tricky. Wait, hang on. Yeah, it's not tricky this way up because I can probe one of the wires. Warmer than your bike ride home though. Oh my god, welcome home, Link! I should do that, but I'm a little bit concerned about why they're not flashing, so let me just double check that I've got all the pins connected correctly. There are no pins coming out of the Arduino before people ask. Like that kept happening last time. They kept falling out of the sockets. They're all in right now. They're all obeying themselves. Pin 2. Was I just about to drag the number 2? I can't even do that now. How did I do that? Do you see that? It showed a weird mouse pointer. I can't even do that normally. What the fuck? Pin 2 to X0. 012 message. Y0, Y1. Data and clock. Oh! Right! We're not using those data and clock pins anymore. Of course, we're using SPI nowadays, right. I'm gonna delete those because they are gonna throw me the fuck off. We're not doing those pins anymore. We're using SPI nowadays. Right. Let's plug those in. I forgot about that. So data is the blue wire? I forget which way around it is on the Arduino every single time. Let's look up that datasheet again. Not datasheet, the webpage. Where was it? Hold on. I've got to find this thing. Arduino SPI pins. Is this one? Nope, that's not telling me. This one? Yes, this one. Yoink. So we've got Mega 52 is clock and 51. Thank you for the pat, Celine. Hi, Lean. Welcome. The pin 51. That's mostly right. One sec. There you go. That's a cute face. Can't believe I've been streaming for 1 hour 14. I haven't done anything yet. Except for tried to get this back into the order it was in yesterday. I mean, whenever I last streamed. Sunday. Thank you, Asinto. Hi, Asinto, as well. Same thing usually happens to me with the SMT32 dev boards, sometimes off by 1 pin. Which things? Oh no, I hope the derpy Yuke doesn't hurt herself. There, cabbage. With the pin. Are you starting to believe the boards are salvageable, or are you just trying to repurpose them to do at least something? They're not salvageable. but I'm bodging them to work well enough that I can run tests that I need to do. Like as much as I can test them through the bodges in order to make the next round not just work as well as this one would have, but hopefully be a little bit better. So partly now I'm trying to test like brightnesses of LEDs and things. That was my plan on this stream. In the hope that I could change which resistors are being used, if necessary. But I can't change the brightness of every single LED individually. I can only change the reason I chose these shift registers is because they're constant current, and you only need one resistor to set the current for all 16 outputs. So that means I can only change the brightness in groups of 16. And it's not really changing the brightness, it's changing the current. So, different LEDs have different ideas of how bright they should be for the same current. Anyway, 51 is data and 52 is clock. Yeah, I think I got it the right way around. So, let's see if that works when I upload it. Oh, wait, I didn't need to re-upload it. Ah, fuck. I just wasted another write cycle. All I needed to do was change which things they're connected to. Okay, let's plug it in. Okay, nice. That works now. Then they look very dim. So it is working. If you're curious how this looks. Well, I was curious though, Sleepy. What is it? You're off with what? Like, not realizing which one is clock and which one's data or something like that? Or you're trying to fine-tune the boards, or at least the bits you're able to do. Got it. Exactly. Maybe you need to use different shift registers of different colored LEDs. Yeah, I would, at this point, it would be nice to be able to use, not a different shift, well, maybe a different shift register. If I can do a power shift register, one that can provide, enough current over multiple ones. Not just the generic shift register, the, whatever the hell it was, HC, something, 74 HC, I forget which number it was. I've got them in a drawer somewhere. I forget what the number is, though. Because they can't supply that much overall. Although maybe I don't need that much overall if the reds are as bright as they are, but anyway, let's show you how this looks now that all the LEDs are on 1/34 duty cycle. Boop, boop. There we are. Much dimmer. You can see the board and you're not blinded by the lights. And that green one looks... the green one looks off. The green one actually looks off. What the fuck? That's how dim it is. That's not dead though. That is actually how it's meant to be according to the datasheet. There you can, from the side, you can see a little dot inside the green one. It is on. I don't think I've mentioned how much I love my current sub badge. She has a star in her eye. Oh no, she does! Wow! That's the tier 2 star. The star appears in a really good position, actually. I didn't realize that. So you can order custom boards. Yes! That is a thing that's possible. Not from me, you can't. Firstly, because this would be so fucking stupidly expensive if I wanted to even break even. Nobody in their right mind would buy these. Because they can be made cheaper, I realize now. And secondly, because I used some commercial software that I don't have I used paid software that I don't have a commercial use license for, so it's just personal use. I wouldn't be able to sell these commercially. Anyway. I guess I could maybe in the future make a board that's like, similar, but done more cheaply and then use a different program like KiCad. Okay, let's change this to use the port B switching method instead of digital write. Now that I'm, got the right fucking wires connected. Okay, so when I upload this, there's a 1 in 34 chance that this is going to get very bright. Or I guess a 2 in 34 chance that at least one of these groups is going to become very bright. Otherwise, they're going to turn off. It just depends where in the refreshing cycle we're up to. Boop! Ah, we lost the gamba. Interesting. So it is not, this writing to the port B thing is actually not working. Oh, for fuck's sake, I'm so stupid. Wait, no, I'm not. No, I'm not. Sorry, I'm not. I mean, I might be, but I'm not for the reason that I thought I was. Okay. Man, I'm going through a roller coaster of self-deprecation and then self-affirmation. What's happening on the pin by scope? That pin is the... Well, it's something that's being held on the screen from a previous probing, but it's still applicable. Well, actually, it was applicable until I just uploaded the last bit of code. Now, hopefully it's a bit faster. Thank you for the pats. I kind of need them, I guess. Personal use only? Why does that look like personal goose almost? Hi, Nikodayo. Thank you as well. The scope reading is just a pin on the Arduino that is pulsed at the start of the cycle of addressing every shift register. So I can measure it and see how long it takes to address every shift register. And I measured 4 such spikes, pulses. Take a close look at that, cat. Because there are going to be 4 boards. So that's like how long it would take to address every shift register on every board. Holy yuck! Alright, why is port B not working? What have I messed up? Latch 10 PWM B bit 4 0 1 2 3 4 port B. This is bitwise ending, right? And bitwise ORing. I'll have a look at the datasheet. Maybe I wrote it down wrongly in my text file. Also, maybe I do, if I'm going to be writing to a port, maybe I do need to explicitly set DDR? The data direction register? B? I forget whether 1 or 0 means input or output though. Is the method wrong or the pulse too short? Wait a minute, that's actually a good point. It could be really fast now, couldn't it? Oh wait, that's actually a good point. I hadn't considered that. Let's add a delay. It's a 1 millisecond delay. This is huge, by the way. Alright, it's uploaded. Oh my fucking god, the pulse was too small. Amazing. Wait, no it wasn't, because the other ones are not working. This is just random. I'm resetting the Arduino again. And again. And now those are on. And again. I'm guessing they're just going to randomly turn on and off. Isn't bit 4 1110 1111 fit 0 indexed? No, this is bit 0 1 2. Oh my god, you're right. What the fuck? Huh? Wait, what the fuck's wrong with me? What is wrong with me? This is embarrassing. 1 2. What the fuck? Thank you. What the hell? How did I... What? What is my brain doing? Clearly I haven't been doing low-level stuff for like too long now. It's been too long since I haven't done the DOS stuff. The DOS stuff. This is why people use hexadecimal? Well, I mean, I'd have to just calculate it still. I could have still made the mistake. In before, I would have typed the number 4, which would have been bit 3 and also wrong. Alright, let's update it. And we're going to remove the delay as well. We'll see if it works. Okay, nice. They're dim. It's working. That means they're turning on and off quickly. Okay. Thank you. Holy crap. I know that some languages let you separate the digits of binary literals, at least. That sounds useful, actually. I still might have got it wrong, though. Oh, I might have realized once I... Yeah, okay, whatever. Anyway, let me probe now and see if it's less than 7.5 milliseconds for a full round of updates. And this is only speeding up the latch, nothing else. The other things can also be sped up. But, you know, I'm out of curiosity. I mean, I'm not out of curiosity. I have plenty of curiosity. But out of curiosity, I want to see how quickly it is. How quick it is. So analog pin 7 is now being probed. Let's take a capture. Boop. Oh, wow! Holy crap! Look at that, at the same time scale. Okay, so now... 1, 2, 3, 4. Wow, look at that. Now it's like... Holy crap, what a big improvement that is. 4.48 milliseconds instead of 7.5. Just by changing these two lines to these two lines. Isn't that ridiculous? If you're ever curious about how slow digital write was, I've just changed this one part. Not any of these parts. Not even any of these. And it's, well, that one's, these aren't gonna make a big difference, but these would. All right. So, I kind of, it would be nice if we could do X0, X1, X2 as well. How was I planning on assigning these bits originally? Port A, shifters index, and channel index, which are what I now call X and Y. I was planning on putting on port A, which is 26, 25, 24, 23, 22. Okay, let's do that. Let's do that. Why not? Let's do it. Let's do it. Unplugging. And critically, the brightness of the LEDs should look pretty much the same. Because the overall cycle is taking the same. I mean the... Oh no, actually they might look slightly brighter. Because the cycle is faster, but the time between these two is less. Sorry, the time between these two hasn't changed. So overall, it's... Oh wait, no, the time between these two has changed as well because pulse latch. The pulse latch is the... Okay, no, that won't have changed brightness. But when I change this, this is going to make the brightness change a bit. Because the time between turning on LED and off the LED will be the same, but the time for the entire cycle will be shorter. So relatively, this will be a higher percentage of the overall cycle time that the LEDs are on for. Hi Annika, welcome, welcome. Okay, so we want port... I'm going to turn off the camera for this. For a moment. I just turned off everything except for the camera. Okay, let's see, where are we? I'm glad the bit thing was correct on there. So 0, 1, and 2 are pins 22, 23, and 24. Alright, I need to move this camera out of the way. I cannot possibly get to the Arduino. Thank you, Cabbage! Actually, you know what? I'll show you a quick view of how this looks right now. On the camera. Why am I being clapped? So, right now this is how it's connected. They're all going to these pins there, at the top of the Arduino. Along there. And I need to change them to happening, like, around there. At the top right of that thick pin header. So let's do it. So what is currently bit 0? It's pin 2, so that becomes 22. So we just need to snake these, or yeah, snake basically. Well, not snake, but step a lot. Why so many claps? I deserve them. Okay. Now's when a pin coming unplugged will be more of a pain in the ass to plug back in, because it's not just a simple row of pins. Okay, so 22. 23. Uh, 24. I'm moving the mic back. 25. It's getting progressively more of a pain in the ass to plug them in as I'm plugging more in. 22, 3, 4, 5. Wait, 2, 3, 4, 5, and 6. Oh, message! The message pin. Oh, the message pin. Okay, message pin. Message pin is in the middle. Alright, now I need to take this wire and put it somewhere else. 24. 25 and 26. Okay, there we are. Now I need to connect this little red wire that is the pin message, which is in the middle of those. Did I guess I wasn't thinking about the... I wasn't thinking about the the pin MSG ones. Was I? Let's have a search. MSG. No, I wasn't. In that case, we could make this. You know what? For ease of wiring, it might help to put the MSG bit here and shove this up to here and shove this up to here. And my only question is, I wonder if the don't set up the party popper it yourself, Cabbage. The puke, I mean. I wonder if it'd be faster. Is it faster to shift by a fewer number of bits? I wonder. On an Atmel processor, Atmega. Because if it is, then I should probably have these down here instead of up here. I wonder. But assuming that it's not, I'm just going to connect these all in order so that I will shove the channel ones up by one. In that case, the red is going to go there.
Gee.
Why shift just all stuff together? Because I have to shift a number that's ranging from 0 to 1. Sorry, 0 to 4, 0 to 3. That is this one that's spelled out in 2 bits into this position on the port. So I need to shift it left by 3 positions, so that instead of appearing in this position on the port, it appears at this position on the port. In the byte, if you like. Okay. Flipping, finally, all the bits are connected. No, it's fine. I really appreciate people like asking stuff, because, you know, it's making me realize mistakes sometimes. So this is MSG. Same as separate bits, not numbers. Why cheese? Hi, Weep Cat. Okay, let's show you the view now. Now it looks like this. Ta-da! There. Look at this mess of twisted wires. Let's hope that it works. Don't forget to pay your cheese tax. There is no cheese tax! There's none! There's none! Silence! Okay, I need to remember how DDRB wires trademark. I need to remember how DDR works. Or DDRA it will be in this case. We're on port A. Okay, so this is old. We're not doing this anymore. We're not doing any of this anymore if we're doing port writes. Not done anymore because we're doing port writes. Let's just copy this. Port A is this. So we don't need to do any of this anymore either. All we need to do is... What do we need to do? I guess we want to... I need to know how do we do the direction? The DDR, the date. I think that's what it sounds for, the data direction register. Let's have a look. Where are we? Arduino... Oh wait, I could have sworn that I... Hold on. I think I've got some information saved somewhere. Where are we? Local docs for the win when possible, right? Port mapping? Port manipulation? Is this the final one? This is the one. Nice. This is from an old docs page. Ta-da! So... DDRD is a direction register for port D. Sets Arduino's pins 1 to 7 as outputs. Okay, so 1 is output. Alright. Well, all of port A are mapped to pins in that little block. So I can easily, safely just say, let's make the entire goddamn port A be output. So DDR-A equals B... I'd say 0xFF. I'll put a semicolon if I can. Let's say, port A pins 22 to 2, 3, 4, 6, 7, 8, 9. Or output. And then port A will actually set the things on the port. We'll call it 1, 1, 1, so it's inverted, and then inactive. Wait, active. Why am I X3? Oh yeah, why? Yeah, that's great. Okay. 1, 1, 1. I mean, I don't care about the last two ones because they're not used. Set port A, yeah. Turn on all bits equals inactive because first revision of board has all of its inputs inverted. Yay! This is a silly little annoyance that will be nice to not have in the end, and we'll just keep doing that way. The latch. Did we change the latch? The latch. Oh, we're doing latch on port B. I guess this could be port A as well, actually, now I think about it. Oh, wait, no, the latch is going to be different. Right, we're going to have 4 different latches for different boards. So yeah, no, we need 4. Yeah, we might as well use another pin where we've got 4 bits free, rather than shoving 2 of the bits onto port A and 2 of the bits onto port B or whatever. Alright, let's change this. So instead of doing it this way, we can simply say port A... how do we do this again? How do we specifically... I think we just OR it, don't we? No, we need to like... Oh! Okay, I want to preserve the top... Is there a graceful way to do this? Must be, right? Effectively, you want to take... Pin missing, inactive. Effectively, you want... That's fine, we don't need to specify this, I guess. This one we do want to specify. Can we just specify them all every time? Can we just say int x ORed with int y shifted left by 4 bits? And yeah, 4 bits because that's probably the fastest way to do it, isn't it? Bitwise XOR plus bit shifting. It's probably faster to just do it this way, actually, now I think about it. Welcome, Ericsson, by the way. Hi. Because the way I was thinking of doing it before was just writing this out and then ORing port A with what it already is and blah, blah, blah. Bitwise XOR plus bit shifting, though. Bitwise XOR plus bit shifting. XOR would be for flipping things, right? What else did XOR do? I think I've used XOR for something. I don't know what it was used for. Hang on a second, it might be in this very document I was just looking at. XOR. Ah, no, it wasn't this one. Or was it? No, it wasn't used for this one. It wasn't in this one. Where was it? Ah, here we are. Wait, no, not that one. This one? Probably. XOR is useful for toggling bits. Yeah. Is this one? Yeah, this is just used for toggling. Yeah. Okay. I was thinking of something else. Never mind. I was thinking about how to modify only a certain number of bits. And then we would just I guess we'd OR it with the current value. So I guess if we want to just modify a certain number of bits, we'd do the alternative of doing it this way. If we set the bits for int y up here and we want to preserve them in port A down here and just only change the int x bits, I'm guessing what we'd do is say port A equals int, sorry, whatever it is currently, and then we preserve those bits, and then we OR it with index. Wait a minute, I wonder if that's faster. That's just an and an OR. Well, I guess it all comes down to, is a left shift faster than and? And is probably faster, right? I have no idea though, and this is an assumption, I don't actually know. You'd OR the changed bits with the rest of the original bits. Yeah. We'd want to like make sure that there's 0 to begin with. Otherwise you would never turn these bits off again. Even if they're low in index. Alright, let's do it this way instead. I've convinced myself. I convinced myself. So we actually want to preserve this one as well. This is the message bit. So here, we just do that. You know what, might as well just say port A equals int y shifted left by 4. And the bit for the message bit, let's define this. Let's define BV for bit val musg. And this is going to be 1 on bit 3. Here. That's a constant, so that's fine. Okay. So we do that once there. That's going to turn off the X pins as well, but I don't really care because we're about to be setting them. Ah, hold on. One more thing. We actually want this to be... Oh... We actually want this to be the opposite, don't we? We actually want this to be the opposite because these pins are fucked. Inverted, sorry. So... Actually, we want this bit to be turned off. Oh, this is a pain. Well, actually it's not. We can just invert the entire thing like this. In this case. Eventually we won't need to do that. And eventually we'll do the same thing here. But eventually we won't need to do this either. Oh, hold on. We want to preserve these bits. We don't care about these bits. I know by doing B00 here, that's if the board were looking at those pins, that would be looking at them as if they were turned on, but those are not even connected to the board, so we can ignore those 2 bits. These ones will preserve whatever the current value is. And then we just need to flip this. I'm just going to put it in parentheses for my small brain. I'm just going to put notes about this. Singular note actually, not multiple notes. Note, bitwise not is only because of inverted board inputs. So that in the future I can remove that, and that'll also be fractionally faster. Port A and blah will keep the top 2 bits, and leave the rest 0. Yeah. Okay, this should hopefully work. Oh, I've got to do this part as well. For the message bits, we just want it to be we only want it to be this, actually. Because we would want... you know what? For the future, for when I have to change it in the future to make it easier for myself, I'm going to write something that's currently redundant, but will make it easier in the future and will be necessary in the future. I'm going to write this and... No, sorry. This or this. Flipped. Even though all we need to really do is this. Without this. At the moment. Because in the future, we'll want to ensure that this is on. I'm just going to copy this one more time. But now, because it's inverted, we want to ensure this bit is off. And the Y bits don't matter at all. Oh my goodness. NPC! Hi! Thank you for the raid! Welcome, welcome! We're glitching into your stream. Welcome! Hi. How was stream? Welcome, NPC. Welcome to Great Kingzilla Inc. Hi! NPC. Euro Truck Sim! I saw it on Twitch's thingy before I saw it on my own setup. $500,000 in debt. Oh my god, it's the true Euro Truck Sim experience. Or X Truck Sim. Welcome. How are you doing? I may have taken a few loans. Oh no, that's so scary to me. I know it's just part of the game. Index will set all of the upper bits on. Disregard the value. So pretty sure you should mask the inverse to affect only the 3 bits. Oh, that's true. Yeah, this would turn on every single bit. Oh yeah, right. Or, yeah. Yeah, that's not right. That's not right at all. I think. Wait, no. In the end... Hang on. In the end... Okay, let me just put this on Notepad. Actually, fuck it. This is a text editor. I'll use it as a text editor underneath here. It's my first time doing any kind of realistic driving sim or driving in general. Using like a pedal and wheels, by any chance? That's pretty cool if you are. And welcome, I'm a strange cat. Currently 2D because sometimes I'm showing a camera view of stuff that I'm working on. Right now it's not super interesting. And normally I'm 3D, but right now I'm not. There you go. That's the live view. Actually, we'll be testing this soon, so I'll need this turned on. I just meant any kind of driving that's not Mario Kart. Oh, okay. Okay. Right, let's write this out. Port A equals something and BV message. Okay, so we have 2 bits that don't matter. Then we've got index Y. And then we've got the message. Anything. I'm gonna write them as X's if we don't... No, X's. Okay, I'll write them as dashes. So this... Well, actually, this is gonna be 0, 0, 0 specifically. We are starting at 0, 0. And then we're gonna flip the entire thing around. I'm sorry to raid and run, but I'm in the process of falling asleep on the spot. Oh my god, please sleep well! Please sleep well! Good night! I made robots with these in college. Hell yeah, nice. That sounds very cool. Wish I had done stuff like that in college. I'm also working on this big circuit board that I made and or had made. I designed it. And it's spoiler, it doesn't work how it is. Version 1 is not working how it's meant to work. Because I made a very silly mistake. And now, but I'm seeing what other testing I can do on it that will work now, that will help me make version 2 a bit better. Flip. Yeah, this is meant to be an LED display, basically to show what's happening in a MIDI file as it plays. All the internal parameters for every one of the 16 channels. It is super cool. It's super cool. It's just a bit of a shame. It's a very, very expensive paperweight, but oh my god, cabbage. Okay, so we start off like this, right? So this, ignoring the flipping right now, we're just looking at this part. So we start off with a value of 0 here. We have the message pin, which will be... Oh, hang on a second. We want this off. Wait, we want this off here. We don't want the message pin on, actually. Yeah, never mind. We actually want that to be nothing. Yeah, ignore that. So we are... What are we doing? We are saying... Oh, I don't need this then. Oh, I guess we could do it that way. We have to do an and either way, so I'll just do it. Okay, whatever. Anyway, one thing at a time. So all we're doing is... That needs to be 0. Here, we've taken this number, ranges from 0 to 3, so it's all going to be 0s to the left. And we also don't care about what's to the left anyway. That's not a thing that I knew I could do. How the hell did I do that? Okay. Ignore the flipping. Yes, ignore the flipping. She flips herself sometimes, Cabbage. It's fine. Select drag. No, I think it was like, was it control? Like start and shift? Wait, what? Start and shift opens something weird on my other monitor. Start and control? I don't know what it was. Anyway, so that makes this. And then what we're going to do is that's going to get inverted. So this is all going to become 1, 1. Our Y is now inverted. 1, 1, 1, 1. But that's fine at this point because we haven't written anything out yet. You know, this is an intermediate value. We don't yet have the value here. Ah, but I'm seeing your... Oh, no, I'm not. No, it's okay. It's still okay. Down here, port A starts off like this. 1, 1, Y, Y, 1, 1, 1, 1. I might as well just have copy and pasted this or cut and pasted. And we're going to OR that with 0, 0, 1, 1, 1, 0, 0. Actually, we don't need the 1. Or do we? No, we actually don't want it. Do we? No, we do want it. We do want to preserve that bit. So we're going to end up with 0, 0, Y, Y, 1, 0, 0, 0. And then we're ORing it with an inverted version of index. So index sits here. And then we're flipping index so that it's, 1, 0, 0, 1. And that's the value that gets written in the end, which is fine. That's what we want. And then down here, we're starting with a brand new value. And we're saying, what is this doing weird indentation stuff for? We're starting with index. So hang on, we've got 0, 0, 0, 0, 0, 0, 0. Then index is going to sit here in the last 3 things. And this message bit, which is bit 4, is going to become 1. And then we're going to flip everything. So this is going to become 1, 1, 1, 1, 0, and then this is flipped. So this here is actually going to change the Y index, but it's fine because the Y is completely ignored if the message bit is set. There's no meaning of MIDI channel if we're addressing one of these special message bits. So this is actually okay as well. So this would be fine. This is going to look to the board like we're addressing channel 0 because these bits are flipped. But no matter what that was, we could be addressing channel 1, channel 2, or channel 3. It ignores those bits. So I think this will work. Now is the time where we see if it will actually work. Inverse of a value flips all the bits, not just 3. Okay, which line are you meaning? I was just trying to flip everything. I'm curious though. Is it, which of the 3 port A's? There are 3 port A's. Is it number 1, number 2, or number 3? The middle one that has note. Okay. So we start off with port A. And port A at this point, okay, I need to work this out again. So ind Y. So 0, 0, 0, 0, 0, 0, 0. And then we have ind Y, which will sit there. And we shove it to the left by 4. So 1, 2, 3, 4. Okay, so we start off with this. And then we flip the whole thing. So 1, 1, those are flipped. 1, 1, 1, 1. I'm going to use lowercase for if they're flipped. So we start off with port A, and we end it with this. So that's 0. Oh, sorry, wait. Yeah, we're ending. So it's 0, 0. These two will remain whatever they were. This one will remain what it was. And these become 0. And then we invert into X. So index is originally sitting here if it were to be board, but we're going to invert that. So now it's XX, and that's what the port becomes. Inverted X. Hang on a second. I've made a mistake somewhere. I should have put 3. No. Oh, X is right. X is 3 bits. Okay. So it becomes that. What is the inverse of index written out as bits? What is the inverse of index written out as bits? Oh, I see what you mean. Right, because XXX, right, because index is actually 8 bits. Right. I see what you mean. Oh my god, that took... Thank you for being so persistent. Holy crap. Yeah. Thank you for the pants, Kingzilla. I'm bad with bit manipulation stuff myself. Apparently I am as well at the moment. Sheesh, hang on a sec, I missed the first message from you. I was doing an online interview yesterday where I had to use various code to control LEDs on a remote device. The interview I made. What the? That sounds awesome! What a fun interview. Wow. That'd be less scary. That's just fun. How cool is that? That's pretty cool. Thank you for the pants. Okay, I see the problem. And again, this is not a thing that would be a problem once I no longer have to flip. But at this point it is. Yeah, at this point it is. Right, so that's what it is. Hey! What the hell? Why? Hi, Liquid. That's why index and that have... Yes, yeah, that makes sense. So at this point, all the pins are gonna be... Oh yeah, no, that's fine. The problem is when we're ORing with the value. Yeah, okay, I think I see it. So it's only a problem because we're ORing it, right? And that would have turned on the bits that we wanted to preserve before. But when we're not trying to preserve existing bits, it's not a problem, I think. No, what you wrote is still... Oh, right. Sorry. I put my thing in the wrong place. That. Oh, that's a typo. So we flip that and then we keep only those bits. Okay, thank you. I just wanted to see what it looked like. Oh, it looks like me in jail. Jeez. I'm gonna have to be quiet soon. And then I'll have to move the vertical keyboard into the correct position. Cheese? No cheese. Nope, absolutely not. Thank you for the pets. Okay. Holy crap. So this should still be faster, even though we're doing a lot of bit manipulation here that won't be necessary eventually. Well, actually, only like 2 bits. That should still be faster than 3 digital writes. Why am I so spooky? The unholy uke. Oh my god. I'm sorry, I keep hiccuping. Okay. Let's see what happens when I connect this. If this works, at this point it's gonna be a miracle. Plug in power. I haven't uploaded it yet.
Oh my god. Okay, it currently... Wait, what's happening? What are you doing to me? Okay, currently it looks like this. And if I wiggle the pins, stuff changes. Also, you can't see anything. That's because those pins are floating within it. Okay, now it's uploaded so it actually controls those pins. Ah! Yeah. Got it. Nothing changed. Man. Yeah, okay, that's not working at all. Nothing's changed. I guess I should be dirty right now. Now might be the time when I need to start probing the main pins themselves, the data pin, not the data pins,
The X and the Y pins. Cause wide spook VT80 uke. Yes. I'm guessing that's a terminal? Historically significant terminal? Okay, I'm gonna need to probe these pins, I think, to see what's going on. Because at this point, I don't know what's happening. So let's find out. Now I need to flip everything upside down. Not really everything, but... what is this view? We need to flip the board. Try not to get it tangled with the webcam cable. Not leave these wires underneath the board. Okay. Okay, it's probing time. Prepare yourself. I think I need multiple probes for this. I'm getting in a tangle. Wires around wires. There we are. Let me prepare a second probe. I think I've seen references to the VT in some Linux shell terminals, as much as I know. Okay. It's more than I know. I think I can actually secure all of these probes in the screw terminal block thingies. By the way, warning in advance, this is not going to be a super clean signal because my ground wire is very long. Actually, I'm not sure if I will be able to. Let's see. Damn, I need a small screwdriver. Hold on. Whose idea was it to use flipping screw block thingies of different sizes? Oh yeah, mine. Why? Can this fit? I don't know if this is fitting. What have I done? Why are the claps so rhythmical right now? What the fuck? Why are they like so rhythmical? What the hell? Why are they all in sync with each other? Okay, I can't fit the pin from the Arduino and the probe thingy. Okay, there we are. That one's a bit more random. A little bit more random. I still hear them synchronizing though.
Clap, 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 clap.
Thank you. It sounds very sarcastic when it's spoken though. I mean, the clapping already sounds kind of sarcastic, but I got used to it. Ooh, hold on. I still have the latch pin on, oh no, that's correct, never mind. The latch pin is on a different port, yeah, that's fine. Okay, the other probe. Like GLaDOS after you beat a level? Yeah. Oh, good. My slow clap module made it in or something. What was the line? I don't remember the line. It's been ages since I played it. Okay, so this is meant to be looking at X0 and X1 only. I'll just prepare this for probing. We don't need the board power on for this actually, which makes it a bit safer. And let's have a look at the oscilloscope view. When you're falling down the very long pit. Yeah. I remember that. Boop. There you go, you can kind of see that I'm probing these two. And let's have a look. What the? Okay, we're seeing something. I'll just turn on the pink one as well. Oh my god. Move it down. By the way, this is what's coming from the Arduino, so this is the opposite of what we should be having. If you know what I mean. What the board should be seeing. So one of them should be switching at double the speed of the other one, because that's how binary works. Yeah, that works. Ignoring the extra long bits in some areas caused by interrupts. Yeah, what? We must be on a really small time scale if interrupts are that long. Yeah, holy crap, okay. Okay, this is running really quickly. It's not working, but it's running really quickly. Alright, so that's working. X1, which is the pink probe, is toggling half the speed of X0. So that's working. Let's probe X0 and X2, and X2 should be switching half the speed of half the speed again. So a quarter of the speed. Let's take a snapshot. On, off, on, off. On, off, on, off. Yep. That's half the speed again. Okay, that's working. Let's going back. Just moving now to probing X2 and X1 as a sanity check. It should look like half the difference again. Nice. Okay, that's working. Alright, let's look at Y0 relative to X2. And that should be half a step down again. Boop. Okay. Wait, this is all really promising. Why is it not working, I wonder? And if I probe X2 and Y1 at the same time, then it should look like 4 times the thing again. Okay, this is working. This is actually working exactly how it should be, which is very nice. All those microseconds. Yeah, this is actually pretty goddamn clean signal as well. Well, I mean, apart from the random bits of interference from the power supply. Okay, that's all good. That's all good. Huh. I wonder if the message bit is wrong. Let's probe. Let's probe X0 and the message bit. And we're gonna want to keep this running and zoom way out. Wait, what the hell? Hang on, is that the message bit? Let's zoom way out. So what should we be seeing here? We should be seeing 32 individual pulses with the message bit high, and then to like 1 pulse, I guess, for the other one. Or 16 pulses because one is one high and 1 low. Okay, hold on, let's zoom in a bit. I'm counting with my finger now, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, this is correct, actually. We are seeing 16 for each of that, for that. Looks pretty clean. It's not bad for the length of the probe wire I'm using. The ground, look at that. That orange wire is going to ground. Not the most ideal probing setup, but it's working. If the BV message should be going to y equals 3, it's actually going to y equals 0. I'm not sure what you mean by that. The BV message is its own thing. So it should be going to bit value 3. And it seems to be working. It's, in any case, the bit value pin is, sorry, the message pin is high from the Arduino. All the time that we should be referencing the normal things, and then it just goes low at the very end for those things. Which is correct, actually. I kind of want to get a 3rd pin on the latch. I kind of want to get a 3rd pin on the latch. Because we should be seeing a pulse from that. Just as a little sanity check. I assume the PS32 or PS3 also sorted the required chips resistors on. Yeah, they did all of the SMD stuff, yes. This is the first time me using them to do SMD stuff though. Using their SMD assembly service. Very happy with it. It's a shame I told them to make nonsense instead of something that works. But they made it exactly how I asked them to. Okay, third probe coming up. Let me just take one, shrink it a bit, and move it up. Channel 3, we'll move down. Somewhere around there. And channel 2, which is pink, we'll move up there. Oops. Scope is kind of laggy when it's working with the sending stuff to the OBS. Trying to connect this third probe's ground. Remove the spring. Okay. Second probe. Oh yeah, I can just probe on the... I'm being stupid. Okay, let's connect this all up again. What a mess of cables I'm holding right now. Oh my god, this is such a mess. Oh my god, this is really hard. This is X. This is the message. I'm gonna latch on the trigger on the message pin actually. One sec. Let's set up channel 2. Well, there we are. And now if I probe the latch pin, which is all the way over. Oh my god, this is tricky. All the way over. Physically, the cables are getting stuck on each other. Okay, latch is there. We should be seeing something that's happening double the speed of the. Ooh, we're seeing nothing actually. Well, we're seeing it stay high. Okay, we're not latching. Interesting. We're not latching. How have we broken latching? Yeah, we're just never latching. The pin is staying high all the time. Huh. Well, there you go. Somehow I broke latching. How have I broken latching? So we're addressing all the correct shift registers, but we're never actually telling them to update. The hell? Pulse latch. Huh. Oh! I removed the part that initializes the latch pin to be in output mode. I see. I see. Right, when I commented out all that stuff, it was actually still doing something important. Whoopsie. Okay. Pod B. I'm going to how do I force on bit? Okay, force on bit one. Let's see. Let's do it this way. So we're doing it this way. Force bit 4 of port B to output mode. They have to be quiet. Let me just go into quiet mode. It's kind of late. Let me go to quiet mode because people are going to be trying to sleep. Give me one sec. Switch to a mode that lets me talk more quietly so you'll actually be able to hear me, like change my noise gate and stuff, and then also switch to a quieter keyboard. Hold please. Untangling. Let me show you what I'm untangling right now. Let us never speak of that again. my keyboard and 3 probes. Oh, a little messed up. Hi Gabriel, welcome. Didn't check my temperature. It's 22 roughly? Very cold for stream. I mean, it's a perfectly nice temperature for me, but my room normally gets stupidly hot, so cold temperature outside means sensible temperature inside. Untangling is in progress. Please wait. Oh, one of those cables was also my webcam cable. Freedom from my day job, aren't I? I'm sorry for you. Oh god. Yeah, okay. I think we're good. By good, I mean still a huge mess, but well, reusable. And let me just adjust some settings. Oh, the music's still loud. Whoops. I just noticed. Oopsie. Boost myself a little bit. Alright, that should be better. You might now hear my probe when I'm speaking. It's very quiet. Unfortunately, that weird burp noise was not quiet. You've seen the mess when I connected 2 KVM switches to USB and 2 monitors to my laptop dock and desktop PC, and then found out it didn't work and had to start swapping cables around. Oh my god! Sounds like a mess. Oh, I didn't move stuff back in position. Bit 4 of port B, so this is latch to output mode. Pin 10 equals latch. Okay, let's see if that fixes it. I will probe though before I connect power. But I just want the satisfaction of seeing that pin doing what I believe it should be doing. Okay, now I need to actually properly untangle these probes. Oh my goodness. Okay. This is gonna take a hot second. I'm disconnecting everything. Alright, yellow probe. That is channel 1. Oh my god, this is... How does it get tangled so quickly? This is crazy. Okay, we've got the first probe. There's his cable. There's proof. It's still a little bit twisted actually. Let's turn it around. Okay, there we go. Then... It's still twisted. How does it keep twisting itself? Okay. Then... Channel 2. Untangling in progress. Please wait. Untangled. I think each successive untangling makes the next one easier. And probe 3. Barely even tangled. Well, I mean it was tangled with itself somehow, but... Oh my god. Yeah, right, my chair's gonna sound a little louder now. Oh my god, what is happening? I thought I just untangled this. How have I just tied a knot in this probe? Wire. Thrilling content. How are you mounting the webcam? Do you have one of those camera mount things? It is taped to a cardboard box, and then there's also an elastic band going around a part of the camera to hold it onto the box, just in case the tape goes weird. Nothing but the highest tech solutions on these streams. So yeah, there's actually a lot of space being taken up on my disk by this cardboard box, but it's also acting as a bit of a barrier between me and the camera, even if it falls off. So it's a bit of a safety thing, kinda. Okay, now connecting the probe's grounds to each other. And we're done. Kinda. We're done, asterisk. Did I upload this? I think I uploaded it. It says done uploading, but I don't know how long ago that message is from, so it's a little bit useless. Okay, so that's X. Oh my god, one of the probe's grounds just came off the other probe's grounders. But how did that one come off? I thought that was the one that was on the more secure way. Clearly not. I'm gonna zoom in slightly on the time axis. Wait, that's out. Oops. I'm so sorry. Okay. Go. X0. Okay. We're probing X0. I'm speaking my untangling noises. Remarkably effect. The camera itself can, yeah, move the box around and wait, why is that looking so weird? Wait, why is it looking so weird? This is like huge interference from my LED lights now, what the fuck? Why? Wait, what did I change? Oh, I never actually connected the real ground. They're just all connected to each other. Yuck, please. Yuck, come on. Okay. X0. There we are. There we are. Thank you. We're triggering on a channel that's not connected yet, so let's connect that one to the message pin. So 0, 1, 2, and then message. There we are. Thank you for the pad scan. Where are we? Here we are. I'm gonna toggle on the slope falling because that's effectively a high value, right? Because, you know, everything's inverted. And then finally, let's probe the latch. And now that should be switching twice as fast as pin 0, X0 is. Because it needs like a full latch on, latch off, even for X0. For each value of X0. And there it is! And one of my probes just fell off again, and now the other one's fallen off. Ah! Come on, this is so fiddly. Amazing, okay, there we are. Trying to hold them on while also not flipping the board. Let's zoom in. Are we getting 2 of the blues for 1 of the yellows? Yeah, we are. Holy crap, look how thin they are! Let's zoom in a bit and take a snapshot. Oh my god, that's so thin! Holy! Look how thin they are! Oh my god! Yeah, there's not been any smoke yet. Let me zoom in even further and just take another snapshot so I can just... Okay. How thin are these? Out of curiosity. This is like the fastest you can toggle a pin on the Arduino without using timer interrupts, I guess. Or hardware PWM, maybe that can go faster, I don't know. But let's see, let's measure. So we'll put one of these there. Like halfway through the thing. Oh, let's zoom in. What am I doing? Take another snapshot. Oh, let me just trigger on this channel. Why am I making it harder for myself? Okay. So this is one of the... Okay, this must be really fast because of how slopey this looks. But yeah, let's measure. Put one of the cursors there. Let's see. Halfway through the thingy. And the other one... What the... The other one... There... Oh, I've got them the wrong way around. I'm saying a negative number, that's silly. $8 megahertz! Oh my god, I just was turning that knob right as I was saying. Okay, so we can toggle on and off a pin in apparently 2 clock cycles. Apparently it takes 2 clock cycles to set the port value. That's amazing. Because the Arduino is running at 16 megahertz. And that pin is lasting, if we were to be continuously toggling that in a loop. Well, not really in a loop, because a loop would add overhead, but you know. Okay, that's really fucking cool. 125 nanoseconds. Wow. And or is 1 clock cycle and setting the pin value another? Maybe. I'm actually really surprised it's that fast. That's amazing. Anyway, I think now that we are pulsing the latch, which we've already determined is not too fast, amazingly, I think it's about time that I turn on the power to the board again. And I need to flip the board again, so give me a sec. The sound of me breaking things, potentially. There's a screenshot right there? Hell yeah. Why am I not able to... Oh, I see. I really hope those LEDs in the back are not getting damaged. Oh, they are kind of... Oh god. Oh god. Oh god, just a little bit. Nah, just a little. That's not good. I mean, I don't really care if they get damaged, but I do care if they start shorting things, but they shouldn't be being shorted. Oh no, exactly. Oh no, she made a mistake. She mishammered something. Okay, not sure what we're gonna see when I turn on the camera now, but let's find out. Oh, that's a bit off. Okay, I'll turn it on and they should appear kind of dim, but not as dim as before. Because the whole cycle is hopefully a lot faster now. So what were we getting before? We were getting like 7.5 microseconds at milliseconds, sorry. Let me make some notes actually. So, I got all the probes on top of my keyboard. Get off! I want to type. Back off. So we had all digital right was 7.5, not 7/5, 7.5 milliseconds per 128 plus 8, 136 shift registers. And port right for latch only took us down to, what was it, 4 point something? Like 4 point something, I don't remember what it was. Shit, I don't remember what it was. Anyone remember? 4.5? 4.6? 7 maybe? 4.7? I don't know. I say approximately 4.75 is somewhere in that region. Milliseconds per 136 shift regs. Now I'm hoping that this is going to make a big difference when I do the last one. We'll see though. We'll see what we get. Let's get in. What's wrong, Sleepy? Hi Minna, welcome. Oh my god, the 2 arrivals. Does this work? First question. Yes! Okay, they're on and they're dim. That means it's working. It's cycling super quickly. So it's time to measure from the debug pin, which we are still pulsing. There is still a digital write happening that won't be necessary eventually, but this is how we're debugging it, so whatever. Let's see if I detach the other probes so I can actually carry the probes easily from one position to another without dragging like half of my desk contents. Let's measure the analog pin. Thank you for the pads, Willy. I thought you shot it. No, I might have damaged something. No, actually, yeah. On the back though. This is a test board anyways. Not a huge deal. I just don't want there to be magic smoke being released because it's scary and smelly. Okay. Give me a sec. There we are. I should do it. I should do it. I'm gonna probe the debug pin now. Let's just reset up this trigger to happen on channel 1. I don't really care whether it's falling or not. Zoom way out. I don't know how far out I need to zoom, but let's see. And we'll probe to... I'm a bit conscious about where this crocodile clip is, but whatever. Pop. I don't like having this ground thing lying around. Okay, is that right? That should be okay. Shorting ground to anything is okay unless we're shorting it to 5 volts. Then that's very, very, very not okay. But shorting it to anything else is okay because these are current regulated shift registers. So it's their job to make sure that not more than a certain amount of current flows. I'm not very happy with how this crocodile clip is sitting there, so let me just change something. Let me do a thingy. Is it gripping? I think it's gripping enough. Okay. It's a bit more isolated now. Nope, it fell off. So here's the thing. The crocodile clip has this little rubber thingy that can go over the end of it. If you see. I've removed it temporarily because it's easier to open. But look at the crocodile clip. It's closed now, okay? This might be hard to see with the camera not focusing very well. But when I slide this cover over the crocodile clip is so wide and the cover is so small that it actually holds the crocodile clip open slightly. This seems like a design flaw. This is impossible to see on the webcam or anything. But it's enough that the thin pin, this... Oh, I can't even get this in view. This becomes... It doesn't grip it anymore. Which is a bit silly. Okay, never mind. That said, it's currently holding it. But it fell out when I did it before. Design error, exactly. Okay, we're measuring our special debug pin, which is out of view. Amazing, Nuke. Good job. There it is. Now let's see how fast it is. Boop. Okay, we've taken our snapshot. Every one of these pulses on the yellow pin is one full border update. So, one full board update. So, 34 shift registers addressed, and there'll be 4 of those boards. So let's once again measure the length of 4 of these pulses. 1, 2, 3, 4. I just noticed it's negative. They're switched, but it's now less than 2 milliseconds. Holy shit! Look at that. It's about 1.92 milliseconds. I'm gonna zoom in and get a closer, more accurate reading. Just put these right around. And that goes there. And this goes 1, 2, 3, 4. There. 1.916 milliseconds, which I'm going to round up to 1.92 milliseconds. The line's so tiny. I know they're ridiculously small, but not as small as the latch ones were. Look, if I zoom in, well, these will look better because these are just done with digital writes, which are way slower. There you are, look at that. Remember how curvy the other one looked? That's because it was at a much smaller time scale. This one looks kind of square. Anyway, 1.92 milliseconds. Holy, that is faster. Okay, I'm not at all worried about how quickly I can update the board now. I know there'll be more processing and stuff, it's not actually going to be as fast as 2 milliseconds when we're done, but like this, I'm happy with the amount of free time we now have between the updates, which is very cool. 500 nanoseconds. How have I not thought of that before? But yeah, 1.92. Okay, so all port rides, except for debug pin, was 1.92 milliseconds per 136 shift registers. That's amazing. Let's align these. What the? Okay. There we are. Hi, Fanana! Welcome, welcome. I'm gonna have to nyan in a very quiet way, which is gonna sound very silly, but it was just requested by Sleepy. 1 sec. There you go. What am I building? I'm working on a circuit board that's... Hang on a second. I used to have... I had like a thing you could type to find out, but I realized I've not enabled it. It's essentially an LED display. It doesn't have many LEDs on it yet, and then this board never will have because it has a mistake that means I have to do these weird bodges, like around those 3 LEDs down there, in order to get it to work. So version 2 will be the one that actually has a lot of LEDs on it, hopefully. But it's an LED message display that should show you what's happening while a MIDI file plays. All of the internal parameters for the 16 MIDI channels. Right now I'm sort of, although the board itself is kind of not easy to use, probably. Thank you for the pants, Spider Cabbage. Kind of logic-wise, it's basically, I don't intend on changing anything, so I'm able to test the software, even though I can't easily see the results in the LEDs that much. But I can like get timings of how long things would take, so actually now I'm not going to need to do much more with the board. I do want to test keeping the green LED on and pulsing the red and the yellow LED in that way that I was thinking of doing before, where I like essentially do pulse width modulation, so the red LED, which is really bright, stays on only for a tiny amount of time, and the other ones stay on for a long amount of time. It's unfortunate that I messed up this thingy as well, the 7-segment display, the way I wired it. I mean, I wired it in a way that I thought would let me bodge it into this board, but now, just earlier in the stream, I actually realized that I mean, I've realized in the past, but yeah, I realized that it wouldn't work because I need one with common positive side instead of common negative side. Anyway. Oops. I'm super lucky that there is an alternative display of the exact same size, just with the LEDs flipped internally. Working on making a brush STC motor controller. Figured I'd see if anyone on Twitch was working on some electronics for the vibes. Oh, nice! That's cool. That's cool. That's more complicated than what I'm doing, I think, because you're getting into like analog territory there, right? Where you're trying to like track the current or something of the coils, or something about the coils, so you can tell the position of the motor when it's time to switch to the next coil. That's black magic to me. I don't know how to do that. I do actually have to take a small break though to save the kidneys. If anybody else, like everybody else, please pay attention to your body and take care of yourself, hydrate and stuff. I'll be right back. You can use this as an opportunity to do it without missing any of the highly interesting things I'm doing. This is sarcasm, because I've just been probing things all stream basically, but anyway, I'll be right back. I returned. Just for fun, went and checked. Oops, press reboot. Just for fun, checked the clock cycle thingy of the latching. Omega 2560. AVR, assembly, instruction, SPI, set bit. Set bit in IO register is 2 clock cycles, so that is the upper limit for latch, and it doesn't matter in that case. I wonder if the compiler then is converting this into 1 instruction. Set bit in port register. That's pretty cool. That's pretty cool. How neat. Okay, I kind of want to try a thing now. I want to try a thing. I want to see how much actually sending real outputs that are not hard-coded slows things down. Because we're at the absolute fastest we can go right now, because we're sending hard-coded values with super fast port accesses. But in the end, these are all going to be read from an array, basically a byte array. Actually, that's a good question. Would it be better to send from a byte array or I mean, this is... It's probably better to send... Yeah, you know what? It'll be a byte array. Even though we're going to do transfer 16, that's fine. This just needs to be what you pass in here, and this is a constant, of course, just needs to be a pointer to the first of a pair of bytes that are going to be sent. And this is going to be one contiguous array. So I'll make it a byte array because I'll only ever need to update like a maximum of 8 pins at a time, or 8 bits at a time. That'll be for the 7-segment displays. 7 bits at a time, I guess, because I'm not using the decimal point. Which is faster on an 8-bit microprocessor, of course, than setting 16 bits. Okay, I'm gonna turn off the power for a moment. Because... Stew! Not because of Stew. Thank you for the pass and the posture check and the hydration. Because I don't want to accidentally show something and make something get all warm and toasty. It's meant to be cold weather outside right now. I don't want to warm it up. Well, it'll be inside weather, but... Okay, let me hydrate. I just ate the kidneys right now. I just got back like maybe 2 minutes ago, Stu. Oops. Thank you. Both chat's been checked. Thanks for the follow, Fernanda. Why are you throwing cheese at me, Psychic? Stop this, this is rude. Not sure about the Arduino Mega, but the Arduino IDE does support debugging. Does this version? This is a fairly old version because I prefer it, frankly. I've never done debugging stuff on the Arduino. I mean, you know, I've done it through serial print and stuff. I once used some simulator which had that feature. Oh, Arduino debugging? That sounds interesting. I wonder if there's a way of getting it to debug at an instruction level. Oh, I'm reading all of these messages in reverse order. That's probably not a very clever idea, is it? Okay, so let's make an array. So here's the thing. We have 136 shift registers, and each of those holds 2 bytes. So we need 272 bytes. That's kind of nice, actually. Yeah, that's not much at all. I thought it was going to be way worse. That's almost nothing, even on an Arduino. That's not a huge deal for like such a project like this. The Mega doesn't support an external debugger. Oh, okay. STM32. Is STM32 another microcontroller? I haven't used one if it is. Well, even if it's not, I've not used it clearly. Knowingly anyway. Alright, let's make something. Shift register data. So is wait, this is gonna be one goddamn thing, isn't it? No, we'll need other things actually. Okay, we're gonna need our main array. Let's call it SR bits, I guess. I don't know. I'm not very inventive, am I? And we need the number of channels, which is 16, times the number of shift registers per channel, which is 8. And then these are the main shift registers, the ones that are showing the bar graphs and the 7-segment display things and stuff. Zoom in a bit. And then we need the special message ones on the end, where there's one shift register for 2 MIDI channels. And so it's 16 over 2. Yeah, that's it. Which is how I end up with the value of 136, if I'm not mistaken. 16 times 8 plus 16 over 2, which is 8. So yeah, okay. I'm almost tempted to make a definition for the number of MIDI channels, which is 16. But like that's not gonna change, is it? I think MIDI is a well-established standard. And like it would be such a much longer thing than 2 characters, like num MIDI channels or something. Versus 16. But maybe it'd make more sense. I'll do it just in case. Times 8. Let's call this num SRs per chan is 8. Fine, we'll do it this way. Fine. So this is channel shift regs plus special instant message LEDs. These are the ones that just flash when a message of a certain type is received. MIDI MPE support. What is MPE? They're a family of chips, the kind of hobby packages known as the blue pill. Okay. In an Arduino Micro type board. Arduino Micro? Oh, it's like microcontroller, or is Arduino Micro actually a type of Arduino? 32-bit ARM with a relatively high frequency. That sounds interesting. Holy, that sounds like massive overkill of what I'm doing right now, to be honest. 70 megahertz. Sheesh. I recently, relatively recently, changed to a newer Arduino version, which is like still, as you can see, not Arduino 2.0 or anything, but, or 2 point anything, but the compiler is much faster than the one I was using before. I don't remember what that was. I think it's 1.6 something. Actually, I can find out. Hold on. It was 1.8.5. Somewhere between 1.8.5 and 1.8.19, which I guess means 19. A big difference was made in compilation speed, like big. MIDI polyphonic expression. Oh, this is this weird bodge to the existing thing, isn't it? I remember looking into that in detail in the server of another techie VTuber channel, Elklunk. Not that he does electronic stuff. Well, I mean, he's actually has made his own Game Boy cartridges, so arguably that is electronics, but the programming was the more impressive part, I guess. Yeah, I remember someone showed me a link to that in his Discord server, actually. Should probably shout him out. He's huge compared to me though, so it feels very weird that someone would know me and not him. But anyway, ta-da! Also has the most flipping cryptic stream titles ever. GBA Homebrew in Lisp at El Kalunk Underworld. There are hundreds of narrow, winding, crawling cracks beneath the surface of the earth. The earth. Wait, this is a remarkably not cryptic title. They're normally much more cryptic than that. I work at a music tech company, so I'm contractually obligated to talk about MP. Ah, okay. Okay, in that case, I feel like I need to get in my head what it is, because I had some opinions about it. I had opinions. Like, there were ways that they could have done things that were a little less... would have been a little more... There are so many unused NRPNs. Why didn't they use some of these NRPNs for the multi-note polyphony? Why didn't they just choose one of the NRPN MSBs to mean this is the whatever the hell it was, the expression. I mean, note after touch is already a thing, right? But why didn't they just use one of the NRPNs to do this is the polyphonic expression, and then use the LSB of the NRPN to be the value for that note? Like, the MSB would be the MIDI note number from 0 to 127, and the LSB would be the value. I guess the only reason that you could say against doing it that way would be speed, because you'd need to send 3 MIDI messages to update the parameter once, wouldn't you? You'd need to send the MSB and the LSB and the... Oh wait, sorry, no, I'm silly. It would just be... Right, sorry, the MSB would be MIDI channel and the LSB would... Wait, no, what am I talking about? Every MIDI channel has its own NRPNs. The MSB... the MSB would be a fixed number. The LSB would be the note number. And the data entry would be the expression value. Right, so it would be 3 MIDI messages, one for the MSB, which one said could be kept the same. One for the LSB, that would be the note number, and one for the data entry. Okay, there we are. Thanks for coming to my extremely long-winded, ranty TED talk that was wrong for like 90% of the time, and I finally cleared up at the end. There are many of those on this channel. Okay, so we've got the bits here. We're not initializing these yet. So... Wasn't there a way... Hang on a second, so this is a Unit 8 team. Wasn't there a way to... TEDx? Yeah, that means that everybody can come to my channel and do TED Talks. That's what that would mean, right? Oh no. The derpuke said... Ah. I have an unhealthy... I don't know. I like MIDI related stuff as well. Hence me making a circuit board for them. So, if you'd like to talk about that here, you're very welcome, Fanana. Anyway, how do we set these all to 0 at the beginning? Is it something silly like equals 0 or something? Or is it like... Or just equals 0 or something? I forget it. Okay, yeah, that compiles. I guess it's that. So I wanted these off by default, and then there'd be an initialization routine which would set them to actually sensible defaults. I'm guessing what we'd actually do is simulate receiving normal MIDI messages. Like, in other words, we'd just simulate receiving like a set volume to 100 message, a set filter cutoff to 64 message, and all that stuff. And we'd process those and work out, okay, if it's 64, then the middle 2 LEDs should be on the bar graph, and we'll turn those LEDs on. I'm not that heavily involved in the whole software side. I'm a mechanical engineer, actually. Oh, okay. The whole thing about MP is that you get per note parameters, where each note becomes its own MIDI channel. So you can do like pitch bends, aftertouch, and a bunch of other expressions on every note. Ah, pitch bend as well. Ah, okay, yeah, bodging in your own pitch bend using NRPNs would be silly. Okay, I was understanding it like expression as literally the expression parameter, which is like a parameter that already exists in MIDI, and I was thinking, well, if you just want to adjust the volume, there's already note aftertouch, per note aftertouch. But yeah, pitch bend would be a bit harder because that's a 15-bit, a 14-bit thing. So you'd need another 2 NRPNs just for that. And bending one bend message, which is normally 3 bytes, would become... what would it become? So instead of a pitch bend, which is 3 bytes, where you have the channel, the high byte and the low byte, where a byte is 7 bits, but whatever, we don't talk about that. We'd have an NRPN MSB value, then we'd have an NRPN LSB for the high, and then data entry, and then an NRPN LSB for the low, and then data entry. And each one of these is 3 bytes, so it'd be 3, 6, 9, 12, 15 bytes instead of 3 bytes. Okay, I can see why that would be very prohibitive. Yeah, okay, that's not good, especially since the MIDI border rate is so low. What do you mean? So it's 31250, right? Divided by 10, divided by 15. Oh my god. You would only be able to do 208 of these per second, which sounds like a lot, but like, not really. Yeah, and then that would be like a completely full serial communication at that point. Maxed out. Yeah, okay. I see why they might want to do it a different way. It feels like such a hack though. Like it's so like not complying with the standard, but I guess the standard didn't have this kind of stuff in mind, did it? So anyway, to answer your original question, no, I don't plan to support that. I don't like have meaningful... I mean, it will show all of the messages that you're actually sending, but it won't like, you know, because MPE is still MIDI messages. It's just using them to mean different things, so it will still interpret. You would still be able to see each of the 16 MIDI channels bending. It's just that like the layout of my board would be implying that those are 16 completely independent instruments. And so the instrument number that is showing for each channel would become irrelevant, I guess, because they would be the same instrument. I guess if I were to make a board that wanted to show that off better, not really sure how I'd do that, to be honest. How would you even demonstrate 16 different pitch bends? Would you just put them like in like 16 columns side by side and say, hey, this is the pitch bend section, and then you'll have another group of 16, I don't know, cutoffs and 16 resos, I don't know. MIDI 2.0. I'm scared of MIDI 2.0, I'm gonna be honest. I'm scared of the lack of compatibility going forward that this is gonna create. I really, really love MIDI for how universal it is. Like, it's been a standard for so long. Isn't it like over 30 years at this point? Around 40 years?
Yes.
Why? That, but it's... I'm sure it's 80 something. I think General MIDI came a bit later. But like MIDI, the original MIDI thing. So General MIDI like assigned names. It decided that, you know, instrument number 0, that is hereby declared to be grand piano. That kind of thing. And standards for what things should initialize as. Are the lights all blinking yet? No, they're not. Oh, well, yeah, they're doing what I wanted them to do. I'm wanting to make them do something else though. Okay, so I'm kind of trying to think about how I'll do this in the future. Let me just get up. Oh, I've already got it loaded actually. It's been sitting here in my taskbar for the entire stream. I haven't clicked on it yet. So here's the board. OG MIDI was 86? That sounds about right, yeah. Let me look at the 3D view because then I can see that. Okay, never mind. Let's reload it. Change literally nothing. Reload it, and then it'll magically work. Years old bug, by the way. Because here I'll be able to see the colors of the LEDs. Obviously, I haven't soldered any LEDs on yet, so this is all stuff that I could change. I could change which LEDs are which. Whoops. Stop doing the silly one. Steady rotation. So... How does it go again? These ones? These two are one shift register. 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Wait, huh? How are these done again? Missed notification. Ah, Pat. Hi 11, welcome. How's it going? It's going okay, thank you. 1, 2, 3, 4, 5, 6, 7. Oh, those two 1 digits are controlled by this shift register that does the other two things. Okay, so they use 15 or 14 of the outputs for the 2 7 segments, and then the last 2 bits, because it's a 16-bit shift register, controls the 2 segments of the fake digit 1. I forgot about that. Okay, so in this case, we've got these 2 columns are all red. Okay. Ah, man. This is annoying, isn't it, actually? I'm just trying to look at every LED that's red to work out which ones I'm going to need to do this weird dimming thing on. So these ones will need to be dim. Some of these might be. I'll have to see how bright they are. The pink probably will need to be. Then our next group has green, red. So again, that is some red. The next one will have red, yellow. The next one has these 2 digits. The next one has 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Oh, hang on. Are these 2 on these? Can't remember. Oh, it's different. We've got 1 shift register for the 2 7-segment displays. We've got 1 for 1, 2, 3, 4, 5, 7, 8. Well, just all this stuff. Are any of those red? Yeah, the pitch bend one is red. Man. And then we have yellow and 3 more reds. Ugh. And then finally we have another 7-segment and some greens. Green being the super goddamn dim ones, which means we'll probably want to dim this display as well. Ah, this sucks. This means we're going to want to be dimming like some LEDs on almost every single shift register. The only ones that we might not want to be dimming are... Oh, this really sucks actually. There is no point to even having a dressing of the shift registers if we're updating every single shift register every single frame. Oh man, this fucking sucks. What a waste of a feature. I could have just chained all the shift registers together and just clocked out everything for all of them on every frame. It would have been a bit faster as well. I pretend I understood what you said. Sorry, Lunk. So basically I have a way of addressing which shift register I want to update. Basically which LEDs I want to update. Which group of 16 LEDs I want to update. Lonky poo. But because the red LEDs are so much brighter than all of the others, I'm gonna have to turn the red ones on for a tiny amount of time and leave the rest on all the time. Per frame. So they just look dimmer overall. Which is a shame. because that means I'm going to need to be addressing every single shift register, every single frame. And the ability to update just one is going to go completely unused. Man. Could you just drop the voltage with some potential dividers? Unfortunately not, because these are constant current shift registers and they are going... Oh, wait, actually I kind of could. This would be like... This would be a very non-standard way of doing things actually. So these are constant current shift registers. But now that I have them, I realized they don't actually have a charge pump in them to get the voltage above the supply voltage if they would need a higher voltage to reach the target current. So in other words, 5 volts are going into the shift registers. And a resistor, it's actually this little one here, for example. This one.
Cheese.
Why cheese? Hey, it was me. This one. These set the target current for each shift register. And it tries to achieve that on every pin independently. Which is really nice, right? But yeah. And you can set the target with that resistor. Between I think 5 and 90 milliamps. And so basically the voltage is going to change to match whatever, you know. It'll use a lower voltage if that's necessary to achieve the set current. Yeah, basically I want to reduce the current that's going to each LED. But the thing is, it's actually not able to lift the input voltage above whatever the input voltage is, which is 5. So I actually could kind of abuse them. And in a way that wouldn't damage them. Well, actually, would it damage them? I actually don't know how they would handle this. Because they have a minimum required, like they say that they can do 5 milliamps minimum, sorry. So I actually don't know. What if you supplied it with less than 5 volts, slightly? Well, what I'm thinking of is if I just add a resistor between the output of the shift register, which is gonna try to make the voltage be whatever it needs to be to achieve 20 milliamps. Not 20 milliamps, what I set it to? 15, I think. I'm gonna reduce that on some of these because it's too bright. The end ones especially. I actually increased the brightness of the end ones because, well, I thought this is such a waste of money though. If I'm gonna start putting resistors on every LED, that's not the waste of money part. The waste of money is using this shift register. Like, I could just not use this shift register. I could use such a much cheap one. This is such a fucking expensive component. But I used it for the convenience. And because I was only going to make this board like as a one-off for myself, so, you know, I guess the price there is like not such a big deal. But, yeah. But the problem is, I would need to like reroute everything if I were to change this. Because different shift registers are not going to have the same pinouts. They're not going to have a place for a resistor for a start, so... like the current setting resistor. But I probably could... I might. This is a thing that I can test actually. I could test this. I don't want to test it tonight because I have to get out my soldering stuff, but... I could test putting a resistor on the output. What about supplying shift resistor with 4.7 or 4.5 volts? I don't know how I'd do that. Thanks, Stu. My camera can see so close and so far in focus at the same time. Look at this depth of field. Thank you for the plus check and hydration as well. And pants. Yeah, I don't really want to do a voltage divider for this. That would be hugely inefficient. Trying to drop the Like, this is going to be drawing, I don't know, maybe 100 milliamps? Well, over 100 milliamps, actually. Trying to do that through a voltage divider's not good at, no, I don't want to do that. It's gonna get, I'd need big resistors. Like, probably physically big resistors. Knees don't need doing yet, thank you, Stewie, the kidneys. I reckon we've got 1 or 2 more hydrations out of this bottle before I need to open a new bottle of Nyan juice. I would be holding up the bottle now, but I'm 2D right now, so I can't. Yeah, there is another world where I designed a board. There's another universe in which I designed a board just using normal shift registers. Well, actually, there need to be power shift registers still, but not constant current shift registers. And a resistor for every LED. That you get linear regulators to do that voltage. No, I wouldn't really want linear either. That would be a lot. It's gonna be somewhere around 5 amps per board, by the way. Adjustable regs. What do you mean by that? But yeah, I'm very reluctant to change any of this because that's huge. Well, I have to remake the board basically. And due to reasons, I wouldn't be able to use the circuit design thingy. Well, I would be starting from scratch if I used the schematic designer to do it. Otherwise, I need to do it all in the PCB thing because there are certain things that changing on the schematic just for some reason rips out all of your tracks and you need to reroute it, and it's really stupid. In fact, it might even require repositioning the components. I can't remember. I remember testing it on stream. Why is the middle mouse button to do this? That's so silly. How micro can a board like this get? Well, I want the LEDs to be a certain size, so... And the initial design of this was dictated by the size of the LEDs. I've tried to pack them in pretty close, though. The gaps between some areas were sort of required for the routing. If you're using surface mount LEDs, you could probably get this smaller. I don't know how much smaller, though. Routing becomes a real pain in the ass when it's small. You can get adjustable LDO. Low dropout something? I don't know what that is. Where you set the output voltage with some resistors. Regulator. Oh! Low dropout, I see. Where you just set the output voltage with some resistors. Cool stuff. As in, like, you need a heatsink, probably. Be able to put out like 1 amp. SO23, SO23. What is SO23? I'd have to have a look. I haven't learned all of these sizes. My name. That sounds quite impressive, actually. But that would be such a disgusting hack on top of this. Mind you, here I am talking about putting resistors on the output of a constant current regulator. So. Which is also disgusting. I might test it. This is so gross though. I might test it on this board, like the one that I have. Putting a resistor between one of the outputs and an LED. I just wonder if it'll work because it has a minimum current that it can achieve. And I don't know what happens if I force it to not be able to push that much current through by using a resistor, you know? Because if it's only going to be able to output 5 volts and I put like a, I don't know, flipping 10k resistor or something obscene, that there's no way it's going to be able to reach the target. And I don't know if that's going to cause issues, like is the output just going to flicker or drop out or something, you know? This is something I need to test. Because it's like out of spec for the chip. It's going to be a very non-standard usage. But that would be, if it works, that's a really disgusting way to fix that. That'd be a lot of SMD resistors as well. Imagine trying to pack in 12 resistors into this area. Which area is it? I think this area. It might just not be super possible. We need to like fit 3 of them there. Some, yeah, I'm not sure this is going to be possible without some big rerouting. I guess this wire could come up through there. Maybe, actually, I don't know if you can fit 2 through there. Oh, you can. Oh wait, that's... Yeah, I don't know. I don't know, this is going to be stupidly tight. I don't know if it's going to be possible. You can get SMD resistor arrays. I don't think that would help here. The problem is routing, finding places to put them in. It might help. I'm not sure though. It might actually help for this area. It might help for this area here, if you can just go straight through there. Maybe. Depends how small they can go, I guess. Hi Hobgoblin. The problem is... I don't know, I was just in the middle of describing it. It took me an extremely long time to describe. I'm not sure I'm ready to describe it again. I'm sorry. I'm pretty sure I went through it on the previous stream as well, though. I'm really not willing to accept the fact that I should trash this entire board and remake a new one from scratch, but that would be the correct thing to do. To maintain the current, then you get a voltage drop across the resistor. I don't know if it'll cut out or not. Like, the datasheet says that it requires some minimum something rather. So, but I can test that, So that's fine. That doesn't need to be like a thing that's... You know. That's a reality that we can measure, rather than just guess. But I'm not gonna do it right now. Thank you for the info, Fanana. I'm not gonna use one of those, I think. I don't like the idea. It's such a silly way. I don't know. I don't even know what the minimum voltage that you can provide this with is. Out of curiosity, let's have a look. Data sheets. Hi, Juice. Three to 5.5 volts, okay. I probably would be okay with that voltage then. I mean, it would be okay with that voltage. But you'd be doing it in order to make it unable to do its job of regulating current. So it's very silly. Also, that would actually not fix the problem. Thank you for the Pat Pool, yeah. It's crazy. Crazily loud, chat. It actually wouldn't work doing this way because the problem is some of the outputs we need to be higher current and some of them we need to be lower current. So yeah. If we just wanted to change the output on all of the pins, we could just change the resistor to a higher or lower? I don't remember which way around it is. Silicon oil. I have never heard of that. I don't know where I'd find that. It sounds like something I'd try to import from America. That's not an oil joke, that's just literally the last time that I was trying to find a very specific thing for real life physical things, which was glue, a very specific glue. I had to import the damn thing from America because I couldn't find it anywhere. The issue is that the pins of each shift resistor are doing a mix of red, yellow and green. Yes! Yeah, it wasn't meant to be an oil joke, I realized how it sounded after I said it. Because I'm sure it'll be some brand name. Even if what it actually is what you said. I should probably look for some brand name. Anyway, I need a new chair anyway. The back doesn't hold its position, which is not great, so I have to have a pillow behind myself. Okay. Well, in this stream I found out that the Arduino is probably absolutely fine up for the job of this timing-wise. It probably would even be up for the job of doing software pulse width modulation on the red LEDs. But... you know, it's an oil on silicone basis, perfect with squeaky plastic and stuff, also for freezing doors. What? Why do you need to freeze a door? Wait, what? For all your door freezing needs. But yeah, as for the hardware itself, I might need to remake it. Man, I'm gonna need to remake this board, aren't I? It's not just that it's gonna be like a huge amount of time and effort. This was like a month-long project, by the way, just to get it to this stage. About 2 and a bit months. But the thing that I'm more worried about, less than, you know, because that was an enjoyable, it was kind of a fun experience being able to stream it. I enjoyed those streams, but the problem is, like, I know exactly what's necessary to get the boards into a working state, you know, ignoring the fact that some LEDs are going to be way too bright with the current board. So, like, this test board will have, like, had more value to it if I, you know, basically, I can, TLDR, I can get this board working. I know how to make, or the next board that I submit, I know should be able to be working based on this board. If I start a whole new board, well, there's like many places where problems that are not currently on this board could be introduced, you know, just by mistake. Obviously, I wouldn't introduce them on purpose, but... And then that would sort of, I guess, delay it even further, and then like the first board of that one's not going to be correct, and then I need to like do what I'm doing with this board now, more tests on the new board in order to get that working, and... I don't know, I'm not made of money. This is expensive. I'd almost rather settle for something that's not perfect. But mind you, if I make a new one, it would be less expensive. Just because I wouldn't be using this really expensive constant current shift register. This is the most expensive part. This costs nearly as much as the all of these components. This component, enough for 5 boards because they assemble 5, cost almost as much as the assembling, the production of the boards and the assembling of the boards, excluding component costs, of course. These are stupidly expensive. As far as a component goes, like it's less than $1 per each, but it's yeah. It's a lot. Like when a car door sometimes is frozen and doesn't open, you can use Vaseline or silicone spray on the rubber so it doesn't freeze. Oh, interesting. Interesting, I didn't know that. Thank you, I'll check that after stream, F-Ball. I can beat that. I made a board with a precision amplifier that cost me $6 for the single chip. Oh my god. Hopefully it didn't have like 136 of them though. I mean, this one of these has 34, but yeah. It'll work. Yeah, fair enough, but I get it. Still valid. So if I were to do this a different way, I would need a shift register that is a power shift register, meaning it can handle a bunch of current going through it. Like a regular 7.4 AC, or whatever the hell the standard one is not up to the job. I think there is one that says it's whatever, able to deal with was it 80 milliamps maximum, I think, which is above something else. But I don't think that's enough for driving 16 LEDs. Well, it might be, but it's a little close for comfort. I'd rather use a shift register that's designed to provide current than sort of abuse one that's more like designed for digital stuff, like logic stuff. But that said, it should still be cheaper than this. What's the logic behind using the constant current registers? Ease. I thought it would reduce the component count, which would make it like easier to do, and yeah, that's basically it. The convenience. It didn't occur to me that there would be such wildly different brightnesses of LEDs. I mean, another option would be different LEDs, but I don't think I could find green ones that were, or red ones that were darker, basically, or green ones that are brighter. Both the red one is both really bright, and the green one is really dark. The yellow one is the only sensible one. Anyway. Imagine if you could just make traces inside, like in the layers, just before the area where it connects to 5 volts, that was so thin they acted as a resistor. That'd be fun. I know that's not within the realms of possibility of this kind of PCB fab, but it would be a fun way to do it with taking up no space. I'm being dumb. If you're just powering LEDs, why isn't constant voltage better? Because different LEDs, the way that LEDs respond to... Well, okay, first of all, it's the current through an LED that determines the brightness. And if this is, say... which way is this going to be? Yeah, if this is voltage, and this is current... That's probably milliamps. Then, as the voltage increases, for some time nothing is going to happen. And then suddenly, it's going to very unstably spike as the voltage increases. And so it's really hard to adjust the brightness of an LED, if you like, based on the voltage. It might also be that it depends on temperature. Like, temperature might determine the exact position of this sort of left and right as well. I'm not sure. So generally you aim for a specific current. Because if you think about it, a diode just tries to pass as much current as possible as long as it's above a threshold voltage, right, which is like normally around 0.6 volts for, you know, a normal silicon diode. And yeah. So an LED, you can think of an LED as being like super greedy with the current. It'll just try and take it all. Because effectively it's a diode in a short circuit, right? If you think of like an ordinary diode, its job is like, you know, to just make things only flow in one direction. If you were to put the diode in a short circuit across the battery, then obviously you would... The diode would die, right? The diode would live up to its name. And die... But yes, you need to limit the current basically, which you do as a resistor, but that's fine. But if you're going to do it with a resistor, you need to know what the forward voltage of the LED is. Effectively, how far along here you need to reach in order for you to reach whatever your desired current is. Die out. That's quite good actually. So this is the forward voltage of the LED, as in like the voltage where it starts in inverted commas. I'm trying to do the hand gestures, but I don't have hand tracking right now. So different LEDs have different forward voltages, and so like if I wanted to make the same current go through the red as through the green, I would probably need a different resistor. But that's also a little irrelevant because for the same current going through it, the green is just darker anyway, so whatever. But that's the main reason that you have to drive a thing based on current. If we have a look at the datasheet for one of the LEDs, which are extremely basic and Chinese. That's soldering. Wavelength, forward voltage, forward current. There you go. So you can see this basically passes nothing, and somewhere, basically the difference between 10 milliamps and 30 milliamps, which is way too much, is what, less than 0.1 volts? Maybe less, yeah, maybe 0.1 volts or so. Is there one that shows, oh there we are, current versus brightness. So, final dumb question, why not the PWM LED driver chip? Maybe I should use one of those, to be honest. Maybe I should. Yeah, maybe I should. I have a question. What is the protocol called that OBS uses to send to Twitch? I keep thinking of RTMP. RTSP? I think. I might be wrong though. Maybe it's RTMP. Yeah, I don't know whether it's RTMP or RTSP. Oh, it is RTMP, okay. Because I know you can do them with both. What I thought the difference was that RTSP was just a secure version, but I don't think that is actually what it means. Like HTTP and HTTPS. I don't think that's what it means though. I know they are both things, so you can send video with the streams. It's very cool how there are so many like people knowledgeable with all kinds of stuff in this chat. Truly a place of education for me. Not sure if anybody else learns. Well, I was just trying to teach, I guess. But where's Arduino gone? Here it is. Warning: if you for some reason like to have your brightness sitting at 100%, a bright thing's gonna be bright. Boop. Is the driver chip TTL or CMOS? If TTL, there will be 0.64 drop from the power rail to the output. If CMOS, it will be much smaller. That will determine the max output current with a high resistance. Well, that's true. If I wanted to calculate it, yeah. I don't know, but I have measured the output of one of these at around 5 volts. So maybe that gives you the answer. But I mean the open load output of one of these. Which also possibly answers my question of being unsure whether it'll work or not with a resistor. If I was seeing 5 volts in an open circuit from the output to 5 volts because they're sinks. Yeah. Huh. I guess that means it might actually just work. I don't know. I have no reference for nits, unfortunately. You know what? We can do one more test. I don't need it connected to the display though. But let's just see what would happen if I actually do turn this on. Sorry. Wait, no, we want them on by default, right? Where's my mouse? Okay. So basically, let's try doing this. Let's try clocking out all of, what's a good way to do this? I think I'm gonna change this. I want to change this actually. I want to put these and then the Y ones in a row, and the message will be separate. Because that way, I can basically treat this as one big 5-bit number, binary number. Hey, I did the thing where I dragged something. Yeah, I want to do it that way. Let's do it that way. I just have to swap around some wires on the Arduino now. Hi, Pika! What if you overclock the LEDs? That's the problem! They're too bright already! Except for the green one. The green ones need to speak up, the red ones need to speak down. What? No. Sorry, I'm just swapping some wires around. PWM? Yeah, that was my original idea. That's probably what I'm gonna do, realistically. That's why I was happy that I was able to get these all 128 being sent in such a short amount of time. The amount of time that's being shown on the scope, right? Oh no, what's being shown on the scope is something else. What the fuck was that? What was the last thing I... Oh, not that you can see it anyway, never mind. Okay, I'm just swapping these around. Orange... Orange goes there, yellow goes there, red goes there. Okay, in that case I'll have two separate arrays for this. This one will be just this. This one will be the shallow shift regs. And then the next one is gonna be Musug bits. I guess I'll call this XY bits and then Musug bits. And this is gonna be num MIDI chans divided by 2. So for debugging, this will have them all be turned on because it's inverted, with making it 0, so everything... Wait, 0. What is this alignment? Main shift regs for each channel. Hi! Wait, what's this button? Hi! BAM! In my mind, the way... The go-to way of driving it is the known current is feed a constant voltage and use a current limit resistor. Yes, exactly. Maybe resistors in series wouldn't work with constant current. That was my original problem. My original concern. But but I think it would be okay because the shift regs can't output more than the input voltage. I thought they could from the datasheet, by the way. I thought they had a charge pump in them that would let them go up to 20 volts. The datasheet wasn't super clear about this. It mentions that 20 volt current generators rated voltage, but this doesn't actually mean that they generate that because I measured 5 volts output. Wait, that shouldn't be what it means though. That should totally be what it means. Oh no, it shouldn't. No, it's fine. You could, right, I see. So you could put 20 volts in through the... Because their current sinks. You could have a separate supply voltage for 20 volts that goes into the positive side of every LED. Then the negative side of the LED goes down to the shift registers. So-called outputs, which are actually sinks. Meanwhile, you power the regulator, the shift register itself with 5 volts. Yeah, I guess that must be what it is. You can't make a charge pump without requiring external capacitors. Oh, interesting. Okay. How fast can you refresh the whole display with the current design? I timed this just earlier. Ta-da! There you go. So yeah, I probably will end up using... Oops. PWM in this. What I don't like about that is that there's no fucking point of having individually addressable shift registers. Excuse my swearing. I might as well just have changed them all together if I'm going to update every shift register and every blah 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 blah. Like the nice thing was that I could just receive one MIDI message that was to do with changing the instrument, and then I just need to update the shift register that shows the instrument number, and that's all. Kind of sad. Kind of sad. Could have been so much more efficient, like software-wise. Maybe this is too cursed. Wouldn't LED in parallel raise the current on the green-yellow LEDs? I don't know. But all of these LEDs should be changeable by themselves. I don't think I am, Kingzilla. I don't know if that answers your question though. That's an interesting first thought though. Ah. Okay, let's see how quickly. By the way, the reason I wanted to change it to be this way. Oh, hang on, I gotta update this first. And why I shifted left by 4, now it's shifted left by 3. That's still correct. That's still correct. Wait, what is this? What is this? Huh? End Y less than 3 space 4. What? What? What is this meant to be? Did I just change that by mistake just now? Oh, I did. What the hell? How did I do that? Maybe I like slapped the numpad or something while I was moving towards the mouse. Okay, I need to change the definition of this and then everything else should just work. So this is now going to be on pin 4... bit 5, right? We use binary code modulation to create the brightness, but it means updating the whole speed at very high speed. Yes, that's exactly what I'm planning on doing. Well, actually, I don't know what binary code modulation is, but essentially, I was just going to turn on everything and then turn off all the reds as quickly as possible, as soon after each other as possible, keeping yellow and green on. Trying to figure out how I measure the phase inductance of a motor using inline current sense amplifiers. See, this analog stuff is actually black magic to me. Good luck though, oh my god. I'm sorry for distracting you from what you're doing as well. You came in here wanting to work along and now here you are. Giving advice. We can make this a feature. If something is clipping, we just flash red full to punish the user by being blinded. Alright, let's change this now to just read through all of this stuff. So, by having something in a loop like this, you know what? We actually don't even need an outer loop anymore. What we could do is just treat the X and Y. Yeah, this is totally a thing that we could do actually. This would be slightly more efficient. Very, very slightly. But we could just have a thing that instead of for each and Y and then X, we just... Yeah, let me change one more thing. Num SRs per module is going to be num SRs per channel times 4. Because there are 4 channels per module. I guess I might as well define this as well. Num mods. Sure. Just for verbosity. If that's how you pronounce that. I don't know if you say verbosity or verbosity. Like velocity. Well, velocity is with a C. Anyway, this is the old way of doing it. I don't need these digital rights anymore. You can get out of here. Yeah, so instead of doing it, no wait, this can go as well. So instead of doing it this way, I'm gonna comment this out. We're gonna do it this way. This is no longer gonna be the X and the Y index. Well, I guess it's gonna be XY, actually. We can call it XY. Oh my god, no, that's an X3. That's kind of funny. It would be less than num SRs per module. Because each module is going to need a different latch, so something's going to be different somewhere. And then we don't need this at all. All we need to do is, well, X and Y are now one big number, so this is just index Y. And we don't need to worry about, we do want to preserve the message bit, but so what we actually want to do is say, oh, this all simplifies a lot. Holy crap, actually. This all simplifies to 1, 2, 3, 4, 5. Wait a minute, doesn't this all just simplify to... I think this all just simplifies to this, effectively. Holy crap. I'm pretty sure that all just simplifies to that. Boss E T. Is that what that means? That's just separating the words rather than saying how they're pronounced. That kind of pronunciation guide and a pronunciation guide with huge quotes, air quotes, bothers me. Verb-based.
Beast.
So this is gonna make X and Y that are inverted, which is fine. It's also gonna flip the pin of the message pin, which is good. And I guess I should make sure this works first. Yeah, I'll keep everything else the same, but afterwards what I want to do is make it read from the array. And basically you can just increment an index into the array. Oh sorry, you can increment the array pointer, I should say, a pointer to the array. And yeah, that will be the... So essentially the pointer is going to start like, so we're going to have a U and a T star, and it's going to be to, let's say, pointer... What do I call it? XY bits. Sure. And this is going to be the address of XY bits at whatever channel we want to start with. Actually, whichever module we want to start with. So it'll be the index of a module multiplied by number of shift registers per module. I think that's how it would work. And we could do a loop for each module, basically. Well, if we did a loop for each module, I'd have to think in the future how to do that. The thing is, for each module, we can't just be in the same loop doing the same thing, because once we get past a quarter of the way through, that is past the first this many bits, in other words, past the first module, we need to start pulsing a different latch, because each module, that is each circuit board, has its own latch. There are 4 circuit boards in total, so 4 independent latches. I think it'll work something like this, just unload more clock cycles. I don't think the problem is clock cycles. Well, I don't know. We're about to find out, I guess, eventually. First thing I want to make sure this still works. BV mistake, order with this will be index Y. Wait, XY? Oh, this just goes from 0 to 1, huh? It's a very weird way of doing it, actually. Oh, actually, when we're moving on to the next pointer, we'll have to remember to increment this by 2. And remember to increment by 2, 16 bits. Okay. Because I'm gonna clock out 16 bits from this pointer position. Eventually, we're not doing this yet. I wanna do the first test first. Oh my god, my mouse is having bad signals. Oh, my Twitch activity feed is very interesting right now. I just noticed it. Look at this. I love being able to see what people are doing. Alright, what else? Message, view message, index X is not really this. Oh, I guess X you could say is 0 or 1. Yeah, I'll keep this bit the same. This will be the same. Oh, this is Windows 10, but yeah. If you compare it to XP, it's quite different, and it's extremely different to 98. I wish I didn't have these stupidly wide things. I wish Windows had actual borders. Well, this one does have a 1 pixel wide border actually, but some Windows don't. This is the best I could manage though on Windows 10. Wonder if someday I'd be able to. Was this indentation always misaligned? Yeah, it was. What the hell? Surprised my OCD didn't catch that. Maybe one day I can do a stream actually using XP or 98 actually. I don't have an XP computer anymore. But I'm not sure what I'd do on it. I mean, the stream would still be coming, like, it would still be my main computer doing the streaming, of course. With OBS and my cursed audio setup and all that stuff. For redeems and everything. But like, I don't know, maybe I can do something on the 98 machine, I'm not sure what. Play some DOS games, I guess? Oh, that's not really needing it's not really needing Windows, is it? Using DOS for that. Well, for the convenience of the restart in MS-DOS mode. Pinball? I wonder if that would work on there. I don't know where to find it. It's not on there by default. I mean, well, it wasn't on this computer anyway. I wonder if it's fast enough. It's a very slow machine. It's a Pentium. Pentium what? Pentium. Install the purple guy. Was that the thingy? I think I've heard people talk about this Bonzo something or other. Again, this is not a thing I was ever exposed to. I was exposed to the MS Agent stuff though. I loved the MS Agent stuff for the TTS. Sappy 4, I think it was back then. I'm not sure though. Maybe not. Maybe it was even earlier than that. What is LOX? Time to overclock to 8 GHz? I don't think it's gonna happen. What is LOX? I know LOX is a game mod for Quake 2 that adds a bunch of fun weapons. Liquid oxygen. Oh, I see. One way to keep the house warm. Yeah, it would be on fire. Alright, this should just work in the same way, I think. Hopefully. Now I've swapped the wires around. Pentium is still not going to consume much. Not well. I mean, you put enough voltage through it. You provide enough voltage. It'll go through anything, even air. Okay, let's upload. Boop. It is uploaded. Let's get the camera on it. Bit of magic smoke, fire, and some marshmallows. Never had the fried or roasted, whatever you call them, marshmallows. Okay, powering on. It works, it works. They're all on dim. That's good. So now let's change it to read from the array, which is gonna look, well, they're just gonna turn on non-stop. But I am doing this because I want to see. Oh, you know what? You know what? Let's have a look and see how if this is any faster. It probably will be slightly faster because we don't have an inner loop. It's not going to be much. Well, actually, it might be a bit faster because we're only modifying the port once per loop as well. You know what? This might be a bit faster. Let's see if we can measure it. So it was 1.95 or 1.92 milliseconds before. This, but only one XY loop. Let's see what it is. I don't want to save it, actually. That was just muscle memory. Let's see if I can get a camera set up for probing. Oh, the camera's still on, whoops. Let's see. Oh, I've got to flip the board the other way around. One sec. Okay. So I want to probe the debug pin on the Arduino, which is pulsing once per loop. And wait, no, that's the only thing I want to probe, actually. That's the only thing I want to probe. Yeah, just that. Ah. The wire fell out of the loose crocodile clip again. Grip my pin. Okay. Let's get the probing. It's just constantly running. And let's have a look. Okay, and there's our thingy. How often is it triggering? Let's slide over a bit till we can fit 4 on there. Oh, well, it hasn't really made much of a difference at all. You can actually see the cursors still set up from before. I guess the compiler optimized something away. In fact, it looks very slightly wider, but it also looks like it's not actually. I mean, it's not measuring 1.92. Whatever. It's basically the same. Well, that didn't make it any faster. Okay. Interesting. A worthwhile test, she tried to convince herself. So now, instead of... what happens if I just turn on all LEDs and I don't turn them off? This should be faster. Like much, you know, like about nearly double the speed, I guess. But there's a reason I'm doing this, because I'm about to be reading from the RAM instead of outputting this constant thing. Now I want a direct one-for-one comparison. So, and then incrementing the pointer as well. So let's see. Let's upload, and this should look a little faster. There it is, way faster. Oops. I'm gonna have to zoom in a bit for this one. Where are we? Where's the begin? There it is. Just to take one snapshot. One snapshot. This is getting so fast now that we can see the up and down of the one pin. That's crazy. So around 982. Let's call it 980. So this was still 1.92. And let's say this, but only LED on, not on plus off, is 0.98 milliseconds. Now, this is the real, actual useful measurement. How is it if we actually do it from memory? So we're gonna have an actual pointer, and instead of doing this, we are going to SPI.transfer 16 bits starting at this position, and then we're going to. I'd love to be able to do. Oh my goodness! Hi, Spheriphoria, welcome. Thank you very much for the raid. Hi. How are you doing? Welcome. Hi, everybody. I'm speaking quietly because, in case anybody wonders, I don't usually speak as quietly. It's just gone midnight. People are trying to sleep. I'm also usually 3D. Anyway, hi. What are you up to? Let me shout you out. Spheriphoria. I don't know if I'm pronouncing that correctly. That's not the right person. I missed an S off the beginning. I just did Feariphoria, which is your Halloween name. I mean, it's not, but I just made it up for you. Take a close look at this cat, by the way. It is past midnight here, unfortunately. Working on my GIMP replacement. Oh my goodness. Shader generated paintbrushes. Wow. That sounds cool. What the hell? You're making your own graphics editing program? Manipulation? Dare I say? Hi, Bob. Arduino. Yeah. We're messing around with. This is a board that I had made, but it's not going to work. So I've had to do. Oh my goodness! I just realized I've bent the LED. It's actually not come detached. Thank you very much for the. I can't actually see who followed me because I wasn't looking at the screen, and my OBS has decided to no longer show me my Twitch feed. It's this amazing white nothingness. I'm very sorry. Thank you, whoever followed. I'm very sorry. I can't see it. But thank you. Yeah, this is a bot I made, but it's not going to work properly because, well, I made mistakes. So I'm just using it for testing as much as I can before I order a second revision, and hopefully that works. And hi, I should introduce myself, shouldn't I? I'm a strange cat who's often does programming stuff. More recently is doing actually electronic stuff. This is only the second stream where I've ever used a camera on stream. For something other than face tracking. And yeah, sometimes I play stuff as well. Anyway, that's all. I don't know what else to say. But how'd it go? How did your stream go? I very much appreciate the raid. Spherophobia. Oh my god, that would be amazing. Or fearophobia. Including sysx in that? Yes, I will. I will include the Roland sysx messages support because I make MIDI files for an old sound canvas synthesizer. So it'd be very cool to add support for showing, like recognizing. Oh my goodness, Clunk! Thank you very much for the flipping gifted sub. That's very funny. I looked at in time this time to see what it was. Actually, that one appears in the chat when the follows don't. Also, hi Clunk. Yeah, I'll be including support for all of the sysx messages that affect any of the LEDs that we're wanting to show. So I'll code support for the sysx alternatives for setting volume, pitch bend sensitivity, which can also be done through NRPNs, or RPNs, sorry, and you know, filter stuff, attack decay, sustain, sustain, release, all that good stuff. I think it's going to be quite fun. You require the sleep, so I'm heading off. Have a nice sleep. Thank you for hanging out. When I wanted to put my face through my desk. Oh my god, I'm sorry. I'm glad you made some progress. Brush generate. Oh, shader generated brushes. That sounds really interesting. Shader generated. So am I remembering the title correctly? Is that what it said? Worked in studios for too many years. Built a SysX dumper and repeater in hardware about 30 years ago. That sounds really cool. What the fuck? A dumper in hardware? What does that even mean?
Cheese.
Stop!
Cheese.
What the hell?
Cheese.
It's too much. Thank you for the pads, dude. Right at the same time as an Omni outburst. An omniburst. Does it like show it on a LCD or something? Just by its... Yeah, but like, how does it... If it dumps it, it's... I assume dumping means it's showing it in some visible way? Like on screen? Or do you mean triggering, like sending a SysX to a synthesizer that would cause it to start outputting a memory dump of itself? Oops. As SysX. Backs up the configuration of physical... Oh, okay. So it stores it to a file somehow, I guess. Interesting. This predated the ability to set up your studio with one click. I know, right? That's really cool, though. That sounds really cool. Did I ever say hi to you all? But hi. I feel like you got a sneaker James May cheese in there. All of the, yeah. The cheeses are inspired by the James May slapping a block of... Oh, by the way, speaking of cheese. On the 23rd of November, which is this coming Saturday, it is my... If I've got the... Hang on, let me double check. Is that right? Yeah, that's right. Oh my god, it's Thursday already. Holy crap! Because it's past midnight here. That is my 3rd streaming anniversary. 30-year streaming anniversary. Or anniversary, I guess. I'm doing it how a friend of mine, Zybite, another streamer, also does it. Basically, she uses this as an opportunity to celebrate, like, streaming anniversary and birthday sort of all in one event. Sort of avoid some doxing stuff as well. Hi Emma, welcome. And yeah, for that reason, because of everybody's clear obsession with cheese, I'm gonna be doing a cheese taste testing stream. I'm gonna be buying, I have a whole bunch of cheeses. Thank you for the pat, thanks. I'm trying to get like a biggest variety that I can, like some from different countries and stuff. Cheese. And yeah, I'm gonna try to sort of, I guess, rank them. I'm not exactly sure. I'm gonna sort of have them in like a cool box with an ice pack in my room. Thankfully the weather's cool right now, so it's not as bad as if it was in the summer. Cheesecake, that'd be interesting. Why cheese-eggs? As a Dutch person, I approve cheese testing. Yeah, funnily enough, the first cheese I ever knew about when I was a child is a Dutch cheese. Which we pronounce as Edam, but I guess Dutchly pronounced would be pronounced Edam. So yeah, I'll try and include some of that. To drop a recommendation, get some
lactose-filled dairy product.
Chows. I don't know what that is. I'm gonna be getting whatever I can, but it's gonna be like it's not being ordered in from online. The first thing I did was have a look online, and someone linked me to a company called the Fine Cheese Company, I think it was called. But holy crap! You're looking for like $100 for a hamper of, what is it, like 5 cheeses, and there are like many other ones. That's like one of the cheaper ones. It's so expensive, so I'm not going to be getting these sort of, whatever the word is, luxury cheeses basically, in like a hamper and everything. I'm just going to be getting small things from supermarkets. I found a bunch that sell a bunch of different ones. Quite a surprising amount for, you know, a random shop in England. Waitrose, okay. Shaos. Okay, I don't know how to pronounce that. I'm guessing the CHA will be... I don't know how the OU
Dear
is.
chat, Yik is an adorable meme. That is all. Continue with your lives.
You're very kind. I'm gonna make a note. Okay, I'm gonna need another notepad. I wanna make it on that one. That'll look very weird. Meow. Thank you for the pad snitch. I mean, Waitrose is expensive, but whatever. cheese from waitress. Showers. I don't know how to pronounce that. Showers. Or something, I don't know how you pronounce that. Favorite cheese. Interesting, interesting. Probably go to a market and ask them to give you one of all the cheese, like a local food market. I have plans. I'll see. I don't know of any local food markets there. Okay, let's try it this way. Let's do it this way now. So we're transferring this, and we're gonna increment PTRXY. Wait, I can. You know what I can do? You know what I can do? I can do a sneaky little thing that will make this look neater. You know what I can do? What I was gonna do was this. But what I could do is just tell the compiler that, hey, this is not an ASMR stream. No, it's 17 minutes past midnight here, so I gotta be quiet. People in the room behind me are sleeping. But welcome in Zippy Snugger. Welcome in Thai as well. My 5 cheese that I've had in my life was so far some 6-year-old aged New Zealand cheddar. I love cheddar. Maybe a little biased. Thank you for the pats, Thai. Yeah. What I could do is just tell the compiler, hey, you know this is like an 8-bit value or a 1-byte value, so you increase it by 1 byte in memory for each number here? No. I want you to pretend that actually this is a 16-bit number. Just cast this to a uint16t star, the address of this. Treat as, I don't need the note. Treat as pointer to 16-bit, so that plus increments by 1 transfer 16 bits. So now all we need to do is this. The sharper the cheddar, the better. Oh yeah, gotta have a very mature cheddar. Ah, wokey hole cheddar. What? This sounds like a meme. Is it actually called that? Did you get things to work? Yes, kind of. I mean, in the sense that I'm just measuring the time it takes for things. I'm about to measure the time it takes for a new thing that I haven't measured before. Let me just do a sanity check. Oh, this isn't going to compile because I don't know what in the mod is yet. Let's just, I guess, pretend that this is a thing. Call it ind mod equals 0. Sure, this is ridiculous. But in the future it'll be this. I'll just hash define it for now, actually. And I can undefine it afterwards, I guess. This is just a placeholder before I actually have a proper loop anyway, so... Times number of shift resistors per mod. This is the thing that's defined, right? Num is ours per mod, which is the number of a channel times the number of mod... What the fuck? That's not right. This should be... Num chans per mod, which is also 4, so it would have worked, but it was the wrong definition. Shift per mod is shift per channel times channels per mod. Yeah, that's right. Shift per channel is 8. Channels per module is 4. Number of modules is 4. Okay, this should work. XY bits is num MIDI chans times shift is per channel. MIDI channels over 2. 1 shift register does 2 channels. That's why I divide by 2. Okay, does this compile? It does. No, I'm loving this. Nerds and cheese. What's not to like? We're gonna get cheese nerds on Saturday. Nice stride hack. Thanks. Although in actual case, in actual fact, this does feel like a more intuitive use because we are transferring 16 bits anyway. Rookie Hole is a cave in Somerset. Interesting, interesting. The code blends. Hopefully it works. Anyway, this is going to be a little bit slower than the timing that you see on the scope right now. So, the timing there, 984 microseconds, is for outputting this. Actually, it's just this part. Sending one hard-coded value. Now, it has to read a couple of bytes from memory, and thank you for the follow, Luxwells! Now it has to read a couple of bytes from memory and increment a pointer in this loop, so it's going to be a bit slower, but like actually doing something that could be meaningful. Oh, I should update this part as well. Yeah, I should update this part as well. We no longer need... Wait, are we doing that one? I guess I'll do the same here. UN16 T star pointer music bits because let's pretend that this is a pointer to a 16-bit thing. I probably don't need as many parentheses as I'm doing, but it makes me feel safer. Music bits. What's the right way to do this here? Maybe I should say num xy's. Because we also want a number of message shift registers. So MIDI channels times number of xy's per channel. And then we're also going to have defined the number of msgs per module, which is 2. Which is essentially the number of chans per module divided by 2. What a weird... Yeah, okay, whatever. This should work. Bit of a weird way that I'm doing it. Number of messages per module. Okay. Just so it makes more sense about how I'm doing this. So index y, num xy's per mod. And this is number, this is int message. And it's the number of messages per module. Where we're using int msg as if it's x. The x value, these bits. I should call this x. Wind of module x index, yeah, okay. So you're treating MIDI signals as bit masks for the LEDs. Does it plug internally, externally? This is purely an LED display. I'm going to receive the MIDI data over a serial port, a UART. Just using the built-in serial capabilities of the Arduino. So it's just going to have the UART running at or looking for bits coming in at the speed of the MIDI, which I believe was 31250 board, somewhere around there. None of this is like for MIDI processing code at the moment though. This is purely for testing, controlling LEDs. I will definitely code the MIDI processing stuff on stream though. I think it's going to be really fun. But I kind of want to have something that can display stuff first. So I'm going to be focusing on getting the display part working first. And that's going to be like a long time before that's done, unfortunately. Because, yeah, this board that I had made was, it doesn't quite work correctly because, 2 reasons. Firstly, the little black squares that you see below each input, below the green screw blocks, Schmidt triggers, and it's not this program, and they're to clean up the signal, basically, that comes in. Snap it cleanly to high if it looks highish and low if it looks lowish. Unfortunately, I got inverting ones, so they snap it to high if it looks lowish and low if it looks highish, which is why I'm doing an inverting thingy every time I'm outputting, and bitwise knotting everything that I'm outputting. So that's a minor annoyance, but the real problem is that the shift registers that are driving all the LEDs are current sinks, not current sources. So instead of like you having a common ground and they're outputting something to every LED and the other side of every LED goes to ground, it's the other way around. You're meant to connect one side of every LED to the power supply, 5 volts, and the other side goes into the shift register as the current sink, and so it accepts the current in. I didn't realize that, and that is unfortunately something I can't easily fix. That's why there is this really hacky way of connecting these LEDs on top, because because the pins that they should go through connect to internal ground planes, which I can't really do anything about. I mean, it's fixed on here now. This is the design. Oh, hang on a second, let me turn off the flipping thing obscuring half the screen that's useless right now. This is the ground layer. Hang on, let me show you. These are the LEDs. And yeah, this is the ground layer. That used to be connecting to this. And this is the 5-volt layer, and now it's connecting there instead. Also, someone asked earlier what circuit design software I'm using. I'm sorry, I just remembered now that I'm on this program that I saw the message, and for some reason didn't get around to answering it. If you're still here, the software is called DipTrace. I don't know how much I could recommend it anymore, because I found some really silly bugs, and I recorded a video demonstrating them and how easy it was and how this could like swap data. You know what, it's so easy to demonstrate, I'll demonstrate it right now. Let's do it. Here we have an LED. This one is 236. Well, more importantly, it says volt. Let me turn on the labels for each of these so you can see this. This is going to look messy, but just so you can see. Okay, so we've got D239, let me change one more thing. Let's make this readable. This would be easy to demonstrate if I hadn't already made the entire goddamn board. Right, we're in. So we have, oh my fucking god. Okay, so we've got these 3 things here. 236, 237, 238, 239. Now, imagine you want to rename one. You can just double click it and type a new name. Like A. Fine. You can double click this and type B. Fine. Double click this. Now look what's happened. I double click this, but you still see the orange dots around this one. But it is showing me the information for 237. So that's fine, right? I'll type C. Oh, okay, this time it actually did update this. That's interesting. Especially in the schematic editor, what it actually does is update this. Actually, no, fuck it, I'm gonna demonstrate this. I'm gonna demonstrate this. I'm not letting it get away with this. Get your ass over here. Symbols. Resistor, sure. Is that a random bunch of random resistors? Bup, 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 bup. Can I have them display their names? Here we are. Let's rename them. A. B. C. D. Oh, hold on a second. It might be more if I press enter. Because it can happen when you press double click as well. Okay, let's do it this way. A. B. C. D. Wait, what the fuck? Why is it... Wait, why is it working now? Wait a minute. Wait a minute, why is this working now? I've recorded a video where this didn't work. What the fuck? What the fuck? Syncing errors. Everyone missed it on a day sheet. I thank you so much. Thank you so much for saying that it's stupid. That makes me feel less absolutely stupid. Because it calls them outputs. It still calls them outputs. I'm gonna get the video where I demonstrated it. By the way, they didn't actually say that when they looked at it. They just said, to avoid this, you can... I can't remember what they said. They said a different way that you could do it, which doesn't actually fix the problem. I'm so determined now to show this. I swear to God, it's not gonna get away with this. I can't keep getting away with this. Where did I put the... Where did my ShareX videos go? There they are. Screenshots. When did I send this? It must have been October or later. Let's have a look. It's gonna be one of these. Bye bye, Sleepy! I'm finding... Oh, actually no, it was later than this. Or earlier than this. Was it really August? Surely not. I would share this on screen, but I'm not sure if something incriminating is gonna appear. Nothing incriminating has happened so far, but I'm just paranoid. It's a bunch of funny, silly things. Huh. For some reason I can't find it right now. This is weird. This is weird. Well, if you want to see it, you can look back at all of the streams where I was designing this and you can see the bug happen many times. I'm sorry that I haven't been able to show it right now. I feel like an idiot. CP, I can't remember if I said already. I might have already said. I think I already did say. I'm gonna try this again. Maybe it was value and not Rift. I think it might have been specifically value and not Refdes, because Refdes is treated in a special way where it tries to make them not duplicates and stuff. Okay, let's try it by changing the name. Demo syndrome. We can use the same component. Oh, this component is schematics. Get over here. Pop. Does it show the name if I type on? A. Yeah, it does. B. C. D. There you go! Did you see that? Let's watch that one more time in slow motion. Which I can't do it in that slow motion because there is a certain amount of timeout. Let's go... Let's make it QWERTY up. Q. W. E. R. Okay, I'm resting my case now. I'm also closing this and not saving changes because I'm a bit scared about what I changed. You can probably find pin for pin Schmidt trigger replacements. Yes, I have replaced the Schmidt triggers already. I have done that already. Maybe even for the other chips. I couldn't find one for the shift registers. That was QSub24. A recent fumble was that amplifier I mentioned earlier. It's an amp used for measuring a Wheatstone bridge. The load cell. No, at all in the datasheet did they mention the current output capability of the amplifier's voltage reference. Just one random diagram where it said if you want to improve the current output, add a transistor like this. So I plug in my 300 ohm load cell and the 10 volt reference drops to 5. The amp is only rated to drive 1 kilo ohm. Huh, interesting, okay. The issue is that the index of the widgets is incorrectly 1 ID less. No, it's actually not that. It's actually not that. It's, hang on, okay, I'm gonna demonstrate more. It's to do with detecting a responding to a double click as if it's a... No, what is it? It's something to do with the timings between the clicks. Because the first one's like, sometimes it comes through correctly. But if I close this and then in quick succession open up another one, like this, then it messes up. But like it's worse than, like, you can't notice it necessarily unless you're looking specifically at where these squares are, because what it shows is the value for the correct one, but what it writes to is the wrong one. So I'm just setting these all up slowly so they'll be correct. Now if I try and change this one and then B and then C to Q and then W. Q. Now look, I double clicked C and it's showing me C, and C is highlighted, but this one's got the dots around it, and I change it and it changes this one. It's such an insidious bug because now, like, the value that you typed is saved in this, but some other ones are... I think the other values remain the same, like R2s remain the same, but... it's to do with, like, the time taken between them. It doesn't need to be that you press enter. It is possible to do it with just, like, okay, double click if I can get it quickly enough. I put it like there. There. That was not even using the keyboard, this was just the mouse. So it's like encouraging you to go like really slowly or just... Anyway, you know what a bigger annoyance is? That can happen while you still have something selected that's off screen. So if you're trying to select this, then it's sometimes it's possible that you think you're changing this one and other ones off screen get changed instead. That happened a few times on the schematic, when I was making the schematic of this. This is the schematic for the thingy. A whole bunch of times I thought I was changing one of these and I was changing like one on a different shift register. Inside here there's like much more stuff, and I would like change something over here and then something on a different one would change. And anyway, this is off topic, but I just wanted to say it because I don't know, I did. Oh yeah, right. The reason I mentioned that is it's because I was saying that I'm not sure if I can recommend DipTrace that much. So I might try and use KiCad for my next project, but KiCad also has city bugs. Since I showed DipTrace, it's only fair that I show a city bug in KiCad. Wait, where is it? Hold on. Where's the project? Where is it? Here we are. So I was thinking of making like a ruler. Oops. Well, holy, the zoom on this is so much more sensitive. So this is like very much... this is KiCad 8, by the way, if I'm not mistaken. Maybe it's not. What's it going to show me if I click this? KiCad 8.06, okay. 0.6. So I wanted to like... What if I want to change these to not be bold? I mean, there's like a bold checkbox right there, right? So maybe I can select multiple ones and it still shows the properties. It does! Very nice. Okay, let's turn it off. Oh, they haven't updated. But look, it has correctly changed the boldness, it just hasn't redrawn them. How do you redraw them? Well, you open it, and then you turn it on, and then you open it, and then you turn it off, and now it's updated. So although you have these convenient ways to change it, they don't make a fucking effect take place. You still have to open the dialog. It looks like you actually don't need to turn it on and off, but you do need to open and close every single one. Which kind of defeats the point of being able to batch change things. Anyway, there we are. Just, there's annoying bugs in there as well. PCBWay one. I don't know what that is. I don't know that program. I think EasyEDA was GLC PCB software. I haven't used that either though. If you change it in the scheme view, like this, the schematic view. I don't have anything on here yet. Oh, while I'm on a ranting about KiCad thing. Actually, no, I'd need to get my facts straight again to be able to rant about that. But yeah, never mind. There is no schematic. Yeah. Okay, I'll save you my rant for the other one. Let's just test this. We've all been waiting to see this, by which I mean I've been waiting to see this. Nobody really cares probably, but let's have a look anyway. So this is going to be a little bit slower than the 984 milliseconds, or microseconds. It better not be 984 milliseconds. That's a second. Almost. Okay, I'm going to click the button. Boop. Num shift traces per mod is not declared. That's true. I changed it to XYs. Also, I never did this thing. I've never finished this line. Music bits. I guess we do care about the module index, the index for the module as well. Here. Times num mods num musics per mod. And then we're not going to output this. Oh shit, I just massively bonked the box of the cameras on. Sorry about that. Then we're instead going to output like this. This is a little bit silly though, because this is just 2 things long. There's a lot of overhead to even use a loop for blah blah blah. To be honest, I'm EDA noob, so my chance of encountering bugs is pretty low. I don't know, I feel like for noobs, these things might be even more annoying because you sort of... It's almost, you know, you're thinking, well, the problem must be with me if it's not working. I must be doing something wrong. And maybe I am doing something wrong with it, but certainly it looks like you should be able to turn on the checkbox for all the things that are selected and have it actually take effect. Even if there was some workaround... Oh, you know what? Let's find out. I'm curious now. If I reload the project, does it draw it with the new things? So if I, for example, make these all italic, does this font work with italic? That's the thing to show first. Yeah, it does. Okay. So I turn that off again. What if I set these 5 to all be italic, and then I save it, and I close it, and I reopen it? Does it redraw it correctly, or does it not? Oof. Oof. It doesn't, but it still says italic here. Oh. I was thinking if there could be a thing you could do to force it to redraw. So it's like storing some redundant data somewhere clearly, right? Because it's storing one representation here and one representation somewhere else. Anyway, okay, let's turn it off again. Huh? What the fuck? It updated to what this was before when it opened, but now it's no longer relevant. Do you see that? Is it even in view? Yeah, it is in view. Half the... sorry, I did it for 1, 2, 3, 4, and 5, but the flipping oscilloscope view is covering somewhere. Okay, so this is now off. And I save it. And I reload it. So this is actually a way to get it to update. Does it only update one of them, or does it update all of them? We're flipping debugging this for them live here. Not really debugging, but just testing. Let's try turning this on. And now it's off. Okay, so no, it only affects the one that's selected. So I could fix these by going on, off. So there is actually a way to make it update. You just have to turn it to the way that you don't want it to be, and then it becomes the way that you do want it. Then you set it back to the way that you do want it to be, and then they're in sync again. Oh boy. Alright, does this compile? Int X was not declared. Oh, what the hell? Whoops. Now? Yay! Inverted logic. It's almost like, what's the word? What is the word? Reverse psychology. It's like, well, you're not gonna do what I do want, so how about you don't do what I don't want or something? I don't even know. There's no way I will drink from that shillick. I didn't know that word. It's clearly poisoned. Oh, okay. Kaget? Yeah. The only thing is, I don't have a commercial use license for dip trays, so if I were to make something in it, I wouldn't be able to sell it. Not that anybody would want to buy this, because it'd have to be sold for stupid money. Didn't break even. But yeah, I'd have to use some other software if I wanted to actually sell stuff that I make. That's why I'm considering trying something else. Because dip trays is really reasonable price for personal use. Or yeah. You have to contact them specifically and say what you want it for, which I found interesting and I thought fair enough. I'm happy about ranting about my projects, so I did anyway. And then they just gave me a license. After I paid, obviously, but for a reduced amount. Anyway, why am I telling you all this personal stuff? Let's just see now what the speed is like. And measure to the debug pin on the Arduino. Okay, I know it's an amazing view on the webcam right now. There you go. So let's see. You need to go to radio and take out your laundry. Oh my god! Do it! Quick! Okay, so this should get a little bit slower. I'm hoping that it lies somewhere between here and here. Actually, it's probably going to be a bit slower than this. I don't know, let's find out. I'm pressing the button to update the oscilloscope. Here we go, 3, 2, 1, boop! What? What? It's the same! What? No way, how is it the same speed to, like, get a value from memory compared to... Huh? How is it the same speed to get a value from memory as it is to do a hard-coded value? I mean, not that I'm complaining. Thank you for the hydration and posture check spray. Is it? Is the compiler realizing that this is never written to? I guess I could make it. Let's make it modify some bit in here just once through the in here. I'll read that message in a sec. And that's it. That's the end of the nyan juice in that bottle. And I have to open a new one next time. So simple. All I have to do is divine from what I know of you. Are you the sort of man who would put the poison into his own goblet or his enemies? Now, a clever man would put the poison into his own goblet. I don't know what this is a reference to. Or a quote from. Because he would know that only a great fool would reach for what he was given. I'm not a great fool, so I can clearly not choose the wine in front of you. But you must have known I was not a great fool. You would have counted on it, so... This is... My brain is breaking here. You would have counted on it, so I can clearly not choose the wine. Okay, this is... Holy shit. The hard-coded value comes from Flash. Yeah, and the other one should come from SRAM. Well, let's just try writing to it. Princess Bride. Prince of Bride. I feel like speech recognition. Yeah, that or you have a very interesting head. My head does weird things like that too sometimes. I mean, my head does plenty of other weird things. I guess nearly 1 AM. It's been fun. I've been chatting like so much more than actually making stuff though. It's enjoyable, eh? Thank you all so much for hanging out and chatting. It makes it fun. Even though I don't get much stuff done. Not that I have a lot of stuff to do, I guess. Oh, I should probably do the thing where it turns... Okay, turn on all LEDs. So let me make sure this is actually working at this point. It should be turning on all LEDs. Like, non-stop telling the shifter to turn on LEDs. And like this is hanging over my board. Thank you for the pats of Paul. Are those pulses supposed to be every cycle? Yes, one of those pulses is every shift register on one circuit board having been addressed. So 4 of those pulses are every shift register on every circuit board being addressed, because there are going to be 4 circuit boards. So the time that's being measured there would be the time to update every shift register on every circuit board, which is really fucking crazy to me. There would be a tiny bit more overhead because some logic would need to go into deciding which latch pin to latch. But yeah. Right, let's turn on the power and see if we are actually making all the LEDs turn on. Right now I have the board upside down, so you're probably going to see some light shining through from down there. And we'll see these ones turn on, which I haven't shown on the stream yet. But since it's addressing every shift register, they should come on as well. Nice! And they have turned on as well. Oh look, you can see the lights shining through the board. Oh, that looks really colourful, what the hell? Okay, that works. When you consider the Arduino clock speed is 16 MHz, 4 kHz is really slow. 4 kHz isn't slow? I mean, we're having to clock out 16 bits for every shift register update as well. And we're doing that at 4 MHz. You know what? I can do that at 8 MHz. Right, why am I still doing it at 4 MHz? Let's do it at 8 MHz. Hi, Doohoo. Welcome. You know what? Let's do it at 8 MHz. The reason I opted to stay at 4 is because the signal looked a little unclean, but since we're pulsing a latch and then immediately unpulsing it, well, and that's happening at 8 MHz, well, that's, you know, why not do the flipping SPI transaction at 8 MHz as well? And this should close to halve the amount of time it's taking again. Obviously, this is where the overhead of the digital write on the debug pin is going to actually start coming. I gotta get hiccups, sorry. Come into play probably. Okay, let's probe this again. I've unplugged power right now. Yeah, so effectively, okay, whatever, let's just update it and see what happens. I'm pretty sure the Arduino was able to clock at 8 MHz. Well, we'll find out now. Yes! Look how close they are now. 1, 2, 3, 4, so it's down to around, let's take a single snapshot. Actually, let's zoom in a bit. One, 2, 3, 4. This is not a super precise reading, but let's call that 620. This but reading from RAM is also 0.98. Hopefully, I haven't guaranteed it yet. And now the same again, but at 8 MHz, not 4 MHz. .62 milliseconds. This is crazily fast. Edge clean this looks okay. Oh, let me zoom in a bit. Oh, actually, you can't see at all. I'm not even probing the thingy. Let's probe the clock. Clock is this one. Run the thing. Let's have a closer look. Hang on, where are we? Position. There we are. There we are. That's... It's just about getting time to... Yeah, but this is 8 MHz, which is like... By the way, this is directly from the Arduino. So I'm not... Oh, you know what? Hang on. Let me probe this properly. Let me probe this properly with that stupidly long ground wire. Let's do it with a proper... we're right next to the ground pin. We can use the spring on the probe. This will probably look a lot cleaner. Well, a bit cleaner. Is it rising edge? Yeah, I do have it set. Yes, yes, it does. It takes the data in on the rising edge. I don't know if you can see this. So I'm using this now. We have the spring on the probe for the ground reference. This should look a lot cleaner. However, this is just the input to the Arduino after it's gone through these cables or wires. Oh, it looks pretty much the same actually. Never mind. It looks quite similar, doesn't it? Maybe, yeah, whatever. This is just what we're getting from the Arduino. This is the right at the entrance of the board. But this is perfectly fine for going through Schmidt triggers, I think. This is the kind of thing that they're meant to clean up. So let's have a look at the output of the Schmidt triggers. By the time the signal reaches the end of the line. So down here are the clock and data pins, after basically as far away from the input as possible. To get there, they have to go essentially, they essentially have to go along up here, and they branch out across each channel. So this is just like the one output has, there's quite a lot of capacitance. This is why I was surprised that it was able to do 4 megahertz. By the way, this does actually work if I plug it in right now while it's running. What should I look at these, I guess? Because that shift register is a bit further along. Oh my god, there you go. But yeah, let me try and probe that. This is not going to be a super clean probe because there is not a ground that I can easily go to. But let me try. Actually, this should be easy to probe, but it's not going to be that clean noise-wise. One of these is clock, one of them is data. I'm not sure which, although it's actually kind of irrelevant because the clock is... Oh no, it is relevant because the clock's going to be half the speed of the data. Oh no, data's not going to do anything. Data's going to be staying high all the time. Or low. High. High all the time. Okay, I'm probing. I'm trying to... Oh, it's probably the wrong one. This one? I'm seeing nothing. What's going on here? Nothing there. Nothing there. What the fuck? So this is not... Feels like the triggers would be trivially delayed. Look at the rise on the clock. You mean by going through the Schmidt trigger? Yeah. I might want to... Okay, oh, that's just me touching the wire. Why am I not getting a reading on this? I feel like I'm doing a very silly thing right now. What am I doing wrong? What am I doing wrong? What am I doing wrong? This worked when I probed it before. What am I doing wrong? I could have sworn that was data and clock. Oops. For some reason, I'm just not getting anything there. Let me flip the board upside down again. So that's the side that I have the lead falling out. Not this time. That happened yesterday. Twice, actually. So, pretty good call. Out of the Arduino. Oh wait, were you there yesterday? I can't remember. So here we have these two wires connected, and that's meant to be the clock and data lines. Instead, I guess I could try probing. Oh, well, literally anywhere else, I guess. For example, that again should be clock and data. But again, I'm seeing nothing on the oscilloscope. What the hell? I mean, clearly the shift registers are getting what they need to getting. Feeling like an idiot. Let's zoom way out and see what the hell's going on. On a bigger scale. Was I just too far zoomed in? Was turn those off. Hey Tilly, I need to go to bed. Fine, no worries, no worries. I hope you managed to get some sleep. Thanks for hanging out. When are you streaming next? I'm not sure. I still need to do 2 more. I try to do 3 streams every week, but it's been getting quite difficult to do. You know, just brain problems and stuff. But I definitely need to do another stream this week because of the cheese taste testing test. Taste stream? Wait, what? Cheese taste testing stream. I'm testing the test. But basically, thanks to you. I'm not sure if it's going to be on Saturday, Fernanda. I'm not sure if I'm going to do it on Saturday. That is the day that will be my 3-year streaming anniversary. I might end up doing it on Friday though. I'm not sure. Because Saturday is often like a hanging out with friends in the evening kind of arranged thing with another streamer. Never liminal. I'm not sure, which I'm very sorry, I'm not sure. I can't arrange things, I'm so useless, and if I arrange things, the problem is that then I'll just be stressed out about it. Even if it's a fun thing. Maybe add some test points in the next revision. Well, I made all of the... That is a good point, I did mean to do that, but I made all of the fires be... whatever the phrase is it untinted? So that, and like, yeah, basically revealable, so you can just solder to them, as I did. Why am I seeing nothing? I mean, I'm seeing a tiny bit of interference from a power supply, I think, but... yeah. No worries, thank you very much for being here, Fernanda. You have a good night as well. No fun allowed, only worry. Yes, exactly, you know how it is. Yeah, I'm a little confused right now about why this is working and simultaneously not. This is probing to 5 volts now. Oh, hang on a second. Oh wait, no, of course, there is no 5 volts on the supply. One sec. I'm gonna do a thing. Oh my god, I'm so stupid! Of course, if I have the power supply for the board turned off, the fucking Schmidt triggers can't run. Of course they're not outputting anything. Okay, I'm plugging the board back in. Okay, it's plugged in. Doohoosh bag. Okay, now I can, the board is on now. Let's just probe to here, I guess. You know what, I'll probe to this one. So one of these is clock and one on stage, I'm not sure which. Let's see. Well, that is certainly cleaner. Look at that. And the reason they're not all the same width and stuff is because I think it's partially because of interrupts, but let's see. Let's try the other pin. Ah, there we are. That's the clock. So it looks like... Wait, no, it was clearly outputting something that's not all 1 bits then. I guess the array is not actually all zeroed out. Interesting. Anyway, here we go. Here's the clock. It looks like this. I think that's fine. Maybe. 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 This is why I was going for 4 megahertz instead. So this is how the signal looks running as 8 megahertz, and if I just keep probing while I change it to 4 megahertz, it goes above the line. That's true, actually. What is this? Wait, that's the wrong one. Oh, also the wrong one. There we are. It's 5 volts per thingy, actually, yeah, so it's actually technically going slightly above 5 volts. Okay, it's probably alright. But just to see how clean it looks at 4 megahertz. I certainly wouldn't want to do 16 megahertz. It might still work if you sort of imagine half of each line being, you know, the length of half the length of each line being chopped away. Anyway, this is 8 megahertz, so I'm uploading now 4 megahertz. There it is. That was interesting. It started... Wait, were we seeing communication with the computer there for a moment? Like we started... What was that? What was that? Let's zoom way out. Oh, why did I just flipping press rule? Let's see. I'll put it back to 8 megahertz. The scope is doing the thing where it clears the screen every time it scrolls across. This is a weird thing it does only when the view is being captured through the web interface, which is how I'm getting it to my computer. Isn't 8 the max from what we found? Yeah, 8 is the max, 8 is the max, yes. Yeah, sorry, I didn't mean that I was considering changing it to 16, yeah. I was just thinking about how clean it would be if there were to be a 16 megahertz signal. But yeah, you're right, 8 is the highest. Let's see what happens. What does it look like when I do this? Upload. What is that? Like, it clearly goes to like a different speed for a moment. Let's, I've paused the thing, let's take a close look. Can't take that close a look because we're only recording at 700 kilobytes per second. Oh, maybe we'd have higher if I turned off the other goddamn channels, but let's zoom in. Is this how it looks when it's running at the high speed? Oh, yeah, it's too fast. Okay, whatever. It's too fast for the sample rate. But anyway, let's look at the other area. I think that was slow enough. Yeah, look at that! Oh yeah, I guess it could be, yeah, right, coupling, yeah, I see, of course. I was wondering, but it looks so clean. But of course, that's because it's going through the shift trigger, the Schmidt trigger, the Schmidt register. Yeah. I wonder if that's 100 hertz. I wonder if that's the mains frequency. Just whip out the cursors and have a look. Where are we? Oh my god, I can't. Would you look at that? It's 50 hertz. It's the mains frequency. Okay, well that covers it. I could actually probe the serial communication. That'd be cool though. Just for fun. Let's have a little fun. Not that I haven't been having fun the entire stream, but let's probe RX. And let's also probe TX. And let's disconnect the power. TX can be on the pink channel. Whoops. Get AC'd on. Let's turn off the camera view because this is going to be nothing. That's not the camera view. Okay, that should work. Ouch. Okay, I'm now going to probe the serial transmit and serial receive on the Arduino. Not in that order. Okay, I think those probes are in far enough. Let's turn this one off. Oh my god, it lags so much sometimes when it's on the thingy. Okay, so yeah, both probes are floating high, or not. I mean, they're showing high because the UART on the Arduino is blah 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 blah. Anyway, let's. I think I'm back. Hi. I'm gonna wait a few seconds for people to roll back in case anybody is still there. Watching. Yep, my thing is not quite ready yet. Hi. Hi. I got a blue screen. I think I need to do the monthly reset of my RAM. I'm very surprised that OBS remembered stuff. Just trying to get the PNG tuber thing back. Here we are. Now I have to do the thing where I choose the sound device every time for some reason. Bop, 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 bop. Okay, nice.
Shut up!
Hello? Oh, right, you're not allowed to minimize PNG tuber plus. Yeah, actual blue screen. Page file in non-paged, or page something in non-paged area or something. I can't remember what the error was. Hi. Thank you for the posture check on the hydration. I guess I'll do it now. Here's a new bottle of Nyan juice that I'm about to open. What a beautiful new bottle. There we are. Nice. Oops. And posture check. Oh my god. Thank you for the pants, Nico. And hi again, Nico, and Spray, and Jokeber, and X, and 11, and Stew, and Four. I'm gonna try to do what I was originally gonna try to do because I'm curious about this, and then I'll end the stream, I think. But I kind of want to do what I was about to try to do because I'm so curious. Programming. What? I can't even see what's happening. Arduino, reopening everything, or just Arduino really, to be honest. Let's see. Oh, OBS did not remember, never mind. Do you want to see what it looks like when I go over to the OBS, the blah blah blah? It looks like this. Perfect. Couldn't ask for more. Also, Arduino didn't remember his thing. Well, never mind. I don't need the webcam for this anyway. Wait, that's the wrong thing. That size? Okay, I am going to flipping probe this thing if it's the last thing I do. Which I hope it's not, but you know. What was the last thing you did? Probe, ma? Okay, I'm gonna click the upload button. It's gonna happen, and we'll see what happens. What information does it show? This is really hard to click the button while keeping the probes in. Okay, I gotta switch to using my left hand on the mouse. Oh my goodness, okay. Boop! This is gonna take a while to compile for the first time. There it goes. There it goes! And it's uploaded! Look at— oh my fucking god, the scope just refreshed. Alright, we're gonna have to do it again. I can zoom in though, it seems. Oh my god, why does it keep refreshing? The scope is gonna destroy my memory. What, are you fucking serious? It just keeps on redrawing everything. Why does it keep doing that? Okay, there we are. I caught it. I have paused it. Let's take a close look. So there's like some serial communication happening when I upload. Look at this. Look at this. The top one is receive on the Arduino. So the top one is computer and the bottom one is Arduino sending. This is maybe not fast enough to decode. Let's see if I can get a slightly faster capture. Wait. No, this is going to be the same. Oh, hang on a second. Yeah, this will be slightly faster. 500 kilosamples per second. I thought it was 700 before, but it's... Anyway, let's have a look. Ah! My wires! Help, everything is falling apart. I'm falling to pieces here. When I raid someone, it's gonna look like I did a tiny stream, which is kind of funny. Actually, I don't know, do other people's shoutouts show how long they were streaming for? Or is it just mine? Okay, let's try this again. Okay, we're ready? Let's give it a go. There we are. Clock is continuing to tick for me. I'm glad. I'm glad time hasn't frozen. Okay, is this decodable? Is that decodable? Should be, right? Do I have a flipping thing limiting bandwidth then? No, I don't. Let's see if we can set up a decoder on this. Function cannot be used in roll mode. I mean, you don't need to be in roll mode. Wait, really? Huh? Wait, what do you mean function cannot be? Oh my god. That's weird. Did I press the wrong damn thing? No. Since when can I not... What? Since when can I not use the decoding thing once if it's paused? What a weird... Huh. But decode is now working. Even though it says it can't be used. Okay, whatever. I'm flipping done with this for now. I am done with this for now. Shutting down. Get out of here. It is now shut down. Well, what a weird end to a stream. Man, I'm sorry my streams are so scuffed. How much do people want to bet that I will have a blue screen? Or just, you know, my computer will fail some way because of the RAM? We need calmer music right now, this is way too intense. How much do people want to bet that during the cheese taste testing stream, we're gonna get that? I would bet something. Have I posture checked? I'm not sure if I've posture checked, I'm doing it now. Done. Alright, well, I think I'm gonna pass you on to somebody now. I do actually need to save the kidneys. So, I'll go and do that. But thank you all very much for bearing with me while I do strange things. Weird, definitely, and wonderful, questionably, things. That's not the thing that I wanted on the screen right now. But oh well. Now you can see how I try to reduce the awkward moments that appear in the address bar. By the way, you can take that as a free VTubing tip from me. Not even VTubing, just streaming in general. If you turn that off, you can type in the address bar and it's safe. Anyway, For some reason that's appearing on the wrong monitor though, so ironically, the stopping of an awkward moment turned into an awkward moment because for some reason that's on the third screen, which is not actually a screen, it's the capture card. Anyway, somehow Nova is still streaming, so I might pass you on to Nova. Actually, Owl is still streaming as well. Owl is doing software and game dev. Thank you very much for being here, Eleven, and thank you for the pad spray. Shush! Silence! Owl. Be quiet. Thank you for the Patsy Amana as well. Riddle me this, Yuki. If the USA is so great, why do they make a USB? Nice. If it happens when we test a blue cheese, I'll lose it. That would be absolutely perfect. That would be perfect. Oh my goodness. Wait, didn't we raid Owl like... Hang on a sec. Am I crazy? Didn't we raid Owl like literally on the last stream on Sunday?
Cheese time.
Or am I going crazy? Hi, Lucky Bad Thing. Welcome, welcome. In that case, I might pass you on to somebody else. I think I'll pass you on to Nova. She's not doing programming, but she very often does. Right now she's playing Factorio though. Oh my goodness, why is my chair making a loud noise? Okay, here's where we're gonna go for now then. To keep it mixed up. If USB is so great, why do they make a USB 3.2 Gen 2? Really? There's 2x2 now? They have 2-dimensional version numbers? Okay, here's where we're going. I would be holding up the placard. Wait, is Shatter not working? Is Shatter not working? Wait, is what the Oh, someone followed earlier as well, 6 minutes ago. Thank you for the follow, Rixcam. It seems that Twitch API stuff might have just broken on my streaming setup as well. It might need a updated token. Amazing. Is it? Wait, no, because someone did the redeems, didn't they? Let me see. Oh, nope, it's broken. Okay, never mind, we've lost connection to Twitch apparently. Somewhere between Stewie redeeming hydration a moment ago and me redeeming RetroCat just now, we lost connection to the Twitch API. Amazing. Okay, anyway, that's going to be all for now. While more stuff continues to break, or before more stuff breaks, actually. Oh wow, I just changed to the perfect ending music as well. Someone smoked a massive crack at the USB headquarters. I am inclined to agree. Gen thing is retroactively renaming previous. So that's even worse. That's even worse. Okay, I'm gone for now. Thank you all very much for being here. I'm gonna try and do 2 more streams this week. Oh my, wait, why is that one come through? Oh, because it's chat. Thank you very much. Oh my god, it kind of almost bounces off correctly. Thank you very much for the flipping bits, Chuckable. Alright, I'm going now. Thank you very much for being here. Bye. Ah! Jesus, that's in like 2 or 3 days. Sorry, I'm gone. Bye. Ah!